Hello, welcome to India's most comprehensive e-learning platform BYJU'S Exam Prep, and also special welcome to electrical as well as instrumentation students for this wonderful great Maha marathon sessions. As you all know, we have started the marathon series quite a long back. However, it is our responsibility to cover the core subjects of electrical as well as instrumentation students. As many students are demanding for measurement session, today I took the privileged opportunity to discuss the entire session related to the measurements. We will try to cover very exclusive and important topics related to measurements in a very short span of time, 3 to 4 hours of session. But trust me, I will cover whatever is required for the GATE examination, and it will be very useful for the students who have already gone through the syllabus and waiting for the revision. Not only for them, even if you are waiting eagerly to write the mock test also, this is a fantastic session. So utilize the opportunity at any cost. If you have any doubts, please feel free to put it in the comment section. I am here to help you at any cost. Clear? So moving ahead, so as you all know, we have started the Maha marathon session long back, 3rd January. However, it's going very fantastic way, and we are almost about to close the sessions because we have already covered all the subjects, right? So before going to the actual session, let me quickly introduce about myself. As you all can see, myself Panindra, all put together, I have an experience of 11 plus years in teaching industry, and till now I have guided more than 50,000. Oh, very good. It's very cool. Okay, Raghuram. First of all, good morning, right? So then enjoy the climate as well as enjoy the classes also. It's always better to learn in the cool mind, okay? But your mind also should be cool, right? So all put together, I have taught more than 50,000 students so far in the subjects of control system and measurements and circuit theory and industrial instrumentation. Clear? So moving ahead to our contents, what we mainly focus in electrical and electronic measurement. Before going to start the things, I would like to recap, or I would like to give you the weightage of this subject especially for electrical and instrumentation students. So from last couple of years, I have been observing that for electrical students, you can expect 3 marks to 4 marks. Okay, so I want to give the exact figure. I don't want to say like it is the 8 marks, 10 marks, something like that. This is the exact figure. Okay, 3 marks to 4 marks. At the same time, Payesh, good morning, Payesh Kumari, right? And for instrumentation student, it is considered as one of the core subject. So for those people, they will be having the weightage of 5 marks to 7 marks. Clear? So this is the general weightage for electrical and electronic measurements for electrical student as well as instrumentation student. Of course, as you know, especially for engineering service examination, this subject is considered as a very valuable subject. Clear? So as I said, we will be mainly focusing on the topics which are very frequent and which are very important. However, if anybody want to go deeply into the subject, already the recorded lectures are available. I have already taken almost around 70 hours of section only on the measurement. You can go through a particular concept where you really find difficulty and get the access and learn very deeply. Okay, right? Kaushal Kumar, good morning. So we start with the error analysis because this seems to be very important topic, not only for electrical students, even for instrumentation students also. And then we will cover PMMC, moving iron instrument, wattmeter, energy meter, and then we will see RLC measurements, especially like DC bridges as well as AC bridges. All those things we will going to discuss in this case. After that, I will explain the concepts of Q meter as well as CRO. At the end, we will see digital voltmeter. So these are the 5. Though it looks like a 5 topics, all put together, it will take a minimum 3 to 4 hours. Clear? So guys, please let me know, are you guys serious about this, energetic about this? Had your breakfast? So in case if you feel any difficult, always feel free to express in the comment section. So shall we start our first question or not? I want great energy from your side because we will be almost 3 to 4 hours, both of us together. So you have to be very sensitive and responsive to my comments. Everyone, Mohan Sai, how are you? After a long time I am seeing you. So let's start with the first question, error analysis. So as you all know, error is byproduct of measurement, right? So whenever you take any measurement, it is a natural tendency to get the error. In general, what you call error? So error definition in people used to say error is equal to measured value minus true value. Then you may ask a question to me, what is this, sir? The definition looks very simple, measured value minus true value. Then why do we require to study so much about it, right? So obviously there are so many things that are associated. Error analysis, even though the initial concepts looks like very simple, if you go deeply, you will find that that itself it is a science. Okay, so let's get into the get into this particular topic deeply. Now let me start with the question number 1. Okay, so today we will do a different approach. We will see question concept. Simultaneously, if you go ahead, then you will also be very interested. Okay, so this idea is given by the students only. A 0 to 250 volt voltmeter has a guaranteed accuracy. This is guaranteed accuracy of 2% of full scale. Clear? Full scale reading. Usually the guaranteed accuracy is always expressed in terms of full scale reading. Please remember this point. Guaranteed accuracy is expressed only in terms of full scale reading. Well, the voltage measured by the voltmeter is 150 volt. Fine. The limiting error in percentage is dash. If you complete the solution, you are always allowed to keep the answer in the comment section. Let me verify that is correct or not. In case if it is wrong, I will notify that. Okay. So first of all, look at the range of the meter. Okay. So first of all, try to keep the range of the voltmeter here. Range of voltmeter. How do we write range of voltmeter? So simple here. So that is going to be 0 to 250 volt. And once you write this way, then find out what is the full scale voltage. Full scale voltage, let us say full scale deflection, that is equal to 250 volt. Correct? Full scale deflection is equal to 250 volt. Whatever you are seeing maximum, that is considered as full scale deflection. Now it was mentioned that 2% of full scale value. Okay, 2% of full scale value. Can you please tell me 2% of FHD is how much here? 2% of FHD is equal to 0.02 into 250, if I am not wrong, right? So how much it will be? It is equal to 5 volt. Am I right or wrong? All of you please mention in the comment section. Kumari and Kumar, both. Kaushal Kumar. So 0.02 into 250, I think it is 5 volt. Yes, yes, Raghuram, good. So this is 5 volt. Now, how do we write the meter specification now? Now there are two ways to write the meter specification. 0 to 250 volt plus or minus, try to remember this one clearly, 2%. This is the way how you should indicate the meter specification, and this is the way how the specification will be given even if you go and buy this voltmeter in the shop. In the electrical or electronic shop, if you buy the voltmeter, they will mention the specification like this. The 1% whatever or 1 or 2% whatever they are mentioning here, this is the 2% of full scale value only, right? So every time the reading whatever is given in the specification of manufacturer book, that is for full scale reading only, right? However, our question is not this, right? So what is our question? He is saying that he took this voltmeter, very fine. He took this voltmeter and he tried to measure only 150 volt. Clear? He tried to measure 150 voltmeter, right? So the voltage measured by the voltmeter is 150 volt. Fine. Then what we should do? So that means you are trying to measure the value. Let us consider this value you are trying to measure. So in that case, this must be said as 150 volt. No problem with this one. This is 150 volt. But you know the accuracy specification of this voltmeter is, right? So let's consider like this. The voltage required to measure by this voltmeter is 150 volt. Then the true value is 150 straight away. If the true value is 150 volt, if you are using this voltmeter to measure this 150 volt, what could be the maximum possible error that you can get? Clear? So that is this voltage. Clear? Every time. This is the meaning of guaranteed accuracy. Some students, they will write like this, right? So some students, they will, instead of 2%, instead of writing 2%, you can even write down this as plus or minus 5 volt. What does it mean? Whatever the value you measure, I repeat, whatever the value, it doesn't matter. There is always a scope of getting plus or minus 5 volt error. Clear? There is a maximum possible error of plus or minus 5 volt. That means even if you are measuring 150 volt here, then the measured value could be either 150 volt plus or minus 5 volt. Clear? you may ask a question to me, how it is, sir, this 5 volt is only for full scale. While you are calculating the specification, you will get by using the full scale. But whether you are measuring 150 volt, 250 volt or 100 volt, you must keep this as a maximum possible error that can be occurred at this particular reading. I hope it is conveyed. Now all of you in the comment section, please let me know, is it clear to you or not? Many of the students, they have a lot of confusion here. That's why I'm again and again stressing this point. Please let me know, confirm in the comment section, then only I will move to the next concept. Okay, so measured value could be 150 volt plus or minus 5 volt. Yes, clear. Then what would be the error now? Now I can say error is equal to, look at that, error is equal to measured value minus true value. I am very sure that then it will become like 150 plus or minus 5 volt, okay, and then minus true value is how much? 150, right? So if you take percentage of error, oh sorry, one second. So let us do one thing. Instead of taking error alone, let me take percentage of error in true value, because that is what is required here, right? So percentage of error in true value. How do we write this one? Measured value minus true value divided by true value into 100. Now relax for some time and make it clear calculation here. So 150 plus or minus 5 volt, okay? So plus or minus 5 minus 150, again 150 here into 100. So anyone, any answer from your side? So I will be very happy to see the answers from your side. I am seeing only 3.33 Mohan Sai has given and Raghuram also has given. So 5 divided by 150, you will be having, yes, into 100. So yes guys, you are right. 3.34 is the correct answer for this question. 3.34%. Clear? Now I will ask a simple question. Right now, everyone use your pen and paper. Answer me fatafat in the comment section. Here, your voltmeter has a capacity to measure from 0 to 250 volt. Okay, that is a specification. But you one second guys. Yeah, is it okay? Yes. Sorry, there is a small issue, I guess. Now, yes. I think there is some little bit technical issue, but I guess now it's clear, right? Okay, fine. Now, what I mean to say here is, your voltmeter has a capacity to measure 250 volt, but you are measuring only 150 volt. That's why your percentage of error will increase when you are measuring lower values than your full scale values here. Clear? Now you can go with one more thing. Instead of going for true value of 150, you go for 100. You go for 100 volt. If true value is 100 volt, then again it will become 100 volt plus or minus 5 volt, and here you will have 5 divided by 100 into 100. That time you will get 5% error. Clear? That time you will get 5% error. So that means even though the accuracy specification is given to full scale reading, one must understand the limiting error percentage will vary depending upon the true value what you are measuring. Clear? So I hope I have conveyed the message of the concept related to the limiting error, and this is the concept of limiting error if you are having only one variable. Now let's go one step beyond that and see the second level of the questions here. So the question is, the DC current I1, I2, I3 meet at a node with I1 entering and I2 and I3 leaving the node. So how it is I1 entering here? So let us say I1 is entering the node here, and I2 and I3 are leaving the nodes. I2 is leaving and even I3 is also leaving. So let me say this is I2 and this is going to be I3. Clear? I2 and I3 both are leaving the node. I1 and I2 are measured as 100 milliampere and 99 milliampere with plus or minus 1% accuracy. Then the value of I3 and its accuracy is going to be dash. Good question this is. In fact, I rate this as a very good question. So let me tell you first what is given here. So they themselves told that the value of specification for I1 equals to 100 milliampere plus or minus 1%, right? Similarly, what about I2 here? I2 is considered as, they are only saying that it is 99 milliampere and plus or minus again 1% here. Clear? Once you write these two things clearly here, you must always understand this fact here. This is considered as a mean value of I1. Always. This is a mean value of I1. That means to measure the current I1, we will take so many readings. Out of so many readings, the mean or the high probable value is considered as 100 milliampere. Clear? So 1% error is the maximum accuracy specification for 100 milliampere. Please note down this point. And this is going to be I2. So first of all, let me tell you in a simple way. I1 is this one, 100 milliampere plus or minus 1%, right? So just give me 1 second, right? So this is considered as a mean value. As I said, mean value of set of readings used only for measurement of I1. Set of readings used only for measurement of I1. Because if I want to measure I1, just like that I cannot take the value. What I do, I will keep a ammeter and I will take 5 to 6 or 10 readings, and the average of 10 readings is coming down to be 100 milliampere. Please keep this point in your mind. It is really very worthful. And this 1%, if you see, what is this 1% here? So delta I1 divided by I1 into 100. This is considered as 1%. Clear? This is considered as 1%. Please note down these 2 points because this is very valuable information. And now, second thing is, look at I2 here. How do we write I2 here? I2 is also same here. What is I2 here? I2 is 99 milliampere. That is the mean value of I2 readings. Plus or minus, once again, this is 1%. How can we write this one now? Now I can say I2, delta I2 divided by I1 into 100 that is equal to, again, this is also equal to 1%, right? This is also equal to 1%. Is it clear so far? Every one of you, every one of you, please let me know. Yes, this is 99 milliampere plus or minus 1%. That is how we are going to get. All of you, only Raghuram is answering. What about Sai and Kaushal Kumar and Kumari, everyone? Please mention in the comment section. Then only I will be understanding whether you are following it or not. Now, we know that from the KCL, at this particular node, I1 is entering and I2, I3 are leaving. So from this, what I can say, it's very simple to understand. I1 is equal to I2 plus I3 here. I1 is equal to I2 plus I3. Therefore, I can say from there, I3 will be equal to I1 minus I2. Please try to remember this one, right? So that means one must understand clearly the limiting error on I3. The limiting error on I3 depends upon the I1 as well as I2. That means I3 is the variable that depends on two more variables. If it depends on two more variables, whether it might be addition or it might be subtraction. I repeat, either it might be addition or subtraction. It really doesn't matter. We will be writing this as, please try to remember this one, delta I3 divided by I3 into 100. Okay, that is equal to plus or minus. Everyone must keep your eyes here. So delta I1 divided by I1 into 100. Okay, into 100. Sorry, I'm extremely sorry, guys. First of all, try to take like this. This is going to be more important and more interesting also. So delta I3 should be taken as plus or minus delta I1 and plus delta I2. This is called maximum possible error that can occur in I3. This is a maximum possible error that can occur in I3. Okay. So what should I say here now? Very good. Mohan has given some answer. So let us see whether that is correct or not. Delta I3 is equal to plus or minus. Now tell me what is delta I1 here. So delta I1 is going to be how much? So if you look at clearly, delta I1 by I1 is equal to 0.01. And from here, delta I1 is equal to 0.01 into 100 milliampere. So therefore, I could say this one as 1 milliampere here. Clear? This is 1. What about this one here? So delta I2 I could say clearly as I obviously again this is also 0.01 into this is I2. I am sorry, this is I2, and I2 already we know that is 99 milliampere. So what should I say? Delta I2 is equal to 0.9 milliampere, if I am not wrong, 0.9 milliampere. Now delta I1 and delta I2 both are known to you. After calculating delta I1 and delta I2, come back here, delta I1 kitna hai idhar? So it is 1 milliampere. What about this one? That is 0.9 milliampere. So therefore we can say both put together it is equal to how much? Plus or minus 1.9 milliampere. This is the maximum possible error that we may get here. Am I right or not? Please all of you check in the comment box and tell me, right? 1.99. Very good. Mohan Sai has given some answer. Let us see now whether that is or wrong. Sir, buffering, what happened to you? Is it okay now? Guys? 1.9 milliampere. But this is delta I3. But what about I3? Possibility of I3 is how much? I3 ka possibility kya hai idhar? So look at that, the plain value of I3 could be calculated as I3 is equal to, already we know I1 minus I2. Mean value of I1 minus mean value of I2. What is the mean value of I1? Mean value of I1 is considered to be 100 milliampere here. 100 milliampere minus mean value of I2 is considered as 99 milliampere. So therefore it is considered as only 1 milliampere. Mohan Sai, you have done the wrong answer. So please look at that. I3 ka actual value is 1 milliampere and the deviation or error could be 1.9 milliampere. Then how do we write delta I3 by I3 into 100? This is what exactly we require. So delta I3 is 1.9 milliampere divided by 1 milliampere here, right? So plus or minus into 100. So obviously how much it will going to become? 1.9 into 100. So am I right? Plus or minus 190%. 190% is the error. How many of you understood this question? Any doubt here? So Mohan Sai, you have committed the mistake while calculating the value of I3 here. Clear? So while calculating the I3 value, you have taken 100 milliampere plus 99. That's why you got 199. But that is wrong answer. You must actually go with the minus here because I3 here is equals to I1 minus I2. Clear? Yes, plus or minus 190%. Good. Very good, Raghuram. Now, I will also tell you one important story here. Just look at this. Suppose y equals to, there is a function y is equal to x1 plus x2. This is a function. Okay. And if you want to get delta y, simple, delta y is equal to plus or minus delta x1 plus delta x2. I cannot derive all the formulas, but I can tell you what is the fundamental logic here. But my suggestion is, if anybody has a doubt how we got this, then please go and refer the recorded lectures available in BYJU'S exam prep. Okay, this is the first condition. And second one already I told you here. So let us take y is equal to x1 minus x2. If you have like this, again delta y could be written as a plus or minus once again delta x1 and again plus delta x2 only. Clear? That is also correct. And suppose third one is y equals to x1 by x2 here. In this case also delta y could be written as plus or minus delta x1 and again plus x2, delta x2 only. Clear? So in all these three cases you will be having same, not only in these three cases, and most interesting part is even in the fourth case, if you see delta y which is equal to x1 into x2, and there also you will going to get delta y maximum value will be plus or minus delta x1 plus delta x2 here. Clear? So this is very, very important. I hope I have conveyed the message so clearly to you. But in case if you really have any doubt, please let me know clearly here. Okay. So is it okay so far? All of you please tell me. 1 second. Otherwise, these two you please keep in your mind. And remaining two we will solve during the, once again we will going to solve here itself. So just keep 1 minute time here for me. Okay. So I will ask one question in the next slide. Then you will going to get a clarity here, right? So this is about error analysis. Now these two I think it is clear to you. Just give me 1 second. Right. Give me 1 second. Third one. Let me take the third one here. Third one. Suppose y equal to x1 into x2. Clear? y equals to x1 into x2, and I need what is delta y by y into 100. This is what I expect. Clear? This is what I expect. How do we get this one? So if you want to get this one, first of all you require delta y. How do we get delta y here? So the delta y could be written as, two variables are there. So we write first dou y by dou x1, clear? Dou y by dou x1 into delta x1 here, and then plus dou y by dou x2 into delta x2. We will take only absolute value modulus of this one, dou y by dou x1 modulus and dou y by dou x2 modulus into delta x2. I am proving it so that you will never get any trouble even if a function is given like product to you. Clear? So delta y is equal to dou y by dou x1 into delta x1 plus dou y by dou x2 into delta x2. Now what is this value? Still if you go ahead, dou y by dou x1, that is nothing but x2 here. So x2 into delta x1 here, and plus what about this one? Dou y by dou x2 is actually nothing but x1 into delta x2. Clear? Now here there is a wonderful mathematics, so please see here all of you. So what I do is I will multiply with the x2 and divide with the x2 here. Clear? And again I will multiply with x1 and divide with the x1. Then this x1 and x2, it could be considered as a y here, and x1 by x1 into x2, it is considered as a y. So we can take y outside. Then you will going to get delta y by y. So please note down this point, everyone. If we are having products like this, then this is going to be delta y by y, which is equal to delta x1 by x1, and then again plus delta x2 by x2 sorry, delta x2 by x2 in delta x2 by x2, delta x2 by x2. And if you want in terms of percentage, delta y by y into 100, this is considered as a percentage of limiting error in the y. I repeat, this is a percentage of percentage of limiting error in y, right? So therefore it could be considered as plus or minus, look at that, percentage of limiting error in x1 and percentage of limiting error in x2. So is it clear to every one of you? Please let me know in the comment section. I just want to know from your side, Raghuram, Mohan, everyone who is there in the comment section, please respond to me, then only I will understand whether you are able to follow this or not. Everyone, please mention in the comment section. This is what you must do when you have a product terminology. And even if it is a division also, you have to approach in the similar fashion. Clear? Yes, clear. Only one clear from Raghuram. What about Kumari and other students? Please let me know, every one of you. Every one of you. Yes, clear, right? Clear. Right. Now let's go to the next one, that is uncertainty analysis here. Okay. So what do you mean by uncertainty analysis here? So first of all, you must notice the difference between percentage of limiting error and uncertainty. Uncertainty is considered as a standard deviation in the measurement. I repeat, it is considered as a standard deviation in the measurement. Clear? Now, simple way I will give it to you. So before going to this question, let me tell you this simple way. Suppose let us say x1, okay? x1 is one reading and the mean value of x1 will be given here, and the standard deviation of x1 will be given something like this. This is the standard deviation of x1 plus or minus delta x1. And suppose x2, lot of readings are taken for x2. Out of that, we have a mean value, and that mean value is considered as x2 bar. Clear? And again, the standard deviation is considered as, delta x2. Clear? So x2 bar is the mean value that is calculated from the set of readings used to measure x2, and delta x2 is considered as a standard deviation. Clear? Delta x2 is considered as a standard deviation. So yes, yeah. Ashish, we can do like that also, no problem. Now moving ahead, x1 and x2, quite obviously it's very well known to you. Now let us say we have a function y. You have a function y where it was mentioned that x1 and x2. Clear? You have a function y where it was mentioned like x1 and x2, and you require to calculate what is the standard deviation in the y. So delta y is now considered as a standard deviation, standard deviation, and delta y by y into 100, it is considered as a uncertainty uncertainty in y. So hope you understood this. Uncertainty in y, calculation of y. So let me write down clearly. This is considered as uncertainty in the calculation of y. So hope you understood this one. But how do we do this? That is a major impact or major difference of the question here, right? So very simple. This is the standard deviation in x. So this is the standard deviation in x. Standard deviation in x. Clear? x1 in x1. So similarly, this is the standard deviation in x2. So let me write down. This is the standard deviation in x2. Okay, in standard deviation in x2. Now relax. What we required is we require the standard deviation in y. So in general, if it is a product form, what we do here, so same thing what we have done earlier, we will be doing the same thing. That is, first of all, let me take, I will show you the procedure also so that you will never find any difficulty anywhere. So first of all, y is equal to x1 into x2, right? So then what is delta y here? Delta y is equal to dou y by dou x1. Of course, you should take modulus of this as I said into delta x1 plus again dou y by dou x2, right? Dou y by dou x2 into delta x2. Clear? Delta x2. Now relax. So it would be considered now as the delta y is equals to, so try to understand dou y by dou x1, obviously it will become x2 here into delta x1 and plus here dou y by dou x2. So it is going to be x1 into delta x2. All these things are fine so far, just one step ahead of our answer. So we must multiply x1 and divide with x1, multiply x2 here and divide with the x2 here. Then this is y and y, similarly like what we have done previously, delta y divided by y, that will be equal to how much here? Delta x1 divided by x1, right? Plus delta x2 divided by x2 here. Clear? Delta x2 divided by x2. Now you must understand clearly, in case of uncertainty analysis, this is the limiting error. This is considered as a limiting error, right? But if you write only like this, delta y by y into 100, which is equal to plus or minus into delta x1 divided by x1 into 100, okay, and plus delta x2 divided by x2 into 100. If you write like this, this is considered as a limiting error. This is considered as a limiting error. I repeat, this is considered as a limiting error. But if you want uncertainty analysis, it is simple. Take the same thing, everything is same, because uncertainty comes from the standard deviation. Everything, the overall procedure is same, but the only difference it comes here. So please try to see, all of you. I think up to here you don't have any doubt. So because this is easy to understand. This is the percentage of limiting error. So this is percentage of limiting error. Limiting error. Now, if you want uncertainty analysis, everything would be same. Delta y by y into 100, right? This is considered as an uncertainty analysis. Uncertainty in y. But in that case, what we do is, we will simply take, okay, under root of, so please try to listen here. We will take under root of this percentage, whatever we have here, delta x1 divided by x1 into 100, okay, whole square and plus, and delta x2 divided by x2 into 100. That's all. Clear? Delta x2 divided by x2 into 100. So I hope I have conveyed the message, and remember that here when you are doing the stepwise procedure is so important. I think I have conveyed the message so clearly to you. Please let me know in the comment section, every one of you, is it clear or not? So this is the uncertainty in y. I need the response from you guys. Please respond in the comment section, every one of you. Everyone, please respond. Right. Uncertainty means simple. Whatever you have done in the limiting error, do the same calculation of limiting error, but at the end, take the under root and keep these forms like this. Okay. Every term must be, squared. Clear? So now moving ahead to the next concept, that is permanent magnet moving coil. Okay. So one second, I would like to ask this question also. Suppose you have a function like this. Okay. Y is equal to, just give me 1 second. 1 second. Yeah. y is equal to x1 into x2 to the power of n. Then how do we calculate the percentage of limiting error? How do we calculate the percentage of limiting error? Once again, it is same. If we calculate limiting error delta y by y into 100 by using the standard procedure, you will get this as delta x1 divided by x1 into 100. Of course, plus or minus will be there here, right? And again plus, if you have power n, then it will become n into delta x2 divided by x2 into 100. This is exactly what you will going to get as percentage of limiting error. Clear? This is percentage of limiting error. However, if you want uncertainty analysis, what we need to do? So this is percentage of limiting error in y. Clear? In y. And delta y by y into 100. Sorry, one second. I'm extremely sorry, guys. Delta y divided by y into 100. In this case, if you want uncertainty, then we must take under root of this, correct? And what should I say? Whatever the terms we have here, delta x1 into x divided by x1 into 100 whole square plus again n into delta x2 divided by, sorry, here a small change, one second. N into delta x2 divided by x2 whole square into 100 whole square. I'm sorry. N into delta x2 divided by x2 into 100 whole square. So the second one is actually called as a percentage of uncertainty in y. Uncertainty in y. See, this is very, very valuable concept. Most of the students, they don't know this uncertainty in y, right? So I have taken a long time to explain these things because wherever you go, the concepts will not be explained so detailed. But those students, even if you are having a doubt, what is this uncertainty and limiting error, abhi tak ye nahi padhaya. So maybe you might be knowing only the concept of limiting error and calculation of limiting error. Many of you are hearing this for the very first time. If you want to know exactly what is the physical difference and actual meaning behind these two, then you need to refer the conceptual sections. Okay, go to the BYJU'S exam prep and look at the recorded lecture. You will be able to understand. Now come to the next concept, that is permanent magnet moving coil. Now tell me, PMMC is a very, very, very basic type instrument, right? It is an indicating type instrument. Of course, it is an analog type instrument, right? It will indicate the value of the voltage or current, whatever you are trying to measure. But one most important and common feature of PMMC is it is the DC type instrument. Clear? It is a very simple DC instrument. If you apply high frequency signal, then it will show the average value of the high frequency signal. Average value of the high frequency signal. Now, let's go to the first question. It was given like DC instrument. Please remember this one. If you give high frequency signal, obviously it will show the average of the sinusoidal signal. If the average is 0, it will show 0. Otherwise, it will show the average of the complete waveform. DC instrument. Now, a periodic voltage waveform is observed on an oscilloscope. Across a load is shown. A permanent magnet moving coil meter is connected across the same load will read the dash, right? So this is a question. So I'll give some time. Every one of you try to answer this one. I am very happy to see the response from you guys. So please try to answer this. Every one of you. Right? So first of all, as I said, it is a device which is capable to measure the DC signal. How we can write the DC? Basically DC is nothing but average value, right? So how can we write average value? V average of the signal could be written as, look at that. Average is nothing but the average value of this voltage signal. How do we write? This is the total area covered here. This is the total area covered. So let me take this area is A1 here. So let me take this area, whatever we do have here. So let me call this one as area A1, and let me take this area particularly as area A2 here, and this area as A3 here. So totally in a single wave or in a single time period, it is having 3 different values here. 4. Mohan Sai has given the answer so quickly. So as of now, everything is clear to you. I think I am moving a little bit fast, but pre-assuming that you all are following me, because many of you might have already watched my recorded lectures, that's why I'm going little bit fast to complete the whole syllabus. So please do respond in the comment section in case if you find any difficulty anywhere. I'm ready to explain to you. Okay, so now look at the overall analogy here. So if you want the average value, then we need to calculate the area A1. First of all, area A1 plus area A2 plus area A3 all the way divided by the total time period here, correct? So first of all, what is the area A1 here? So look at that area A1, right? Area under the, yes, thank you very much, Kumari. Area A1 is nothing but half into base into height, correct? It's a triangle. So therefore, half into base is 10 millisecond. So 10 into 10 power minus 3 millisecond means into. So it is 10 and millisecond is the range. Height is how much? 10 volt. So 10 volts. So let me write down. This is how much here. So it would be 50 into 10 to the power of minus 3. Let's keep that one aside. And what about A2 here? A2 would be written as, look at that, A2 is 10 to 2. This is 2 only. Time base it is 2, but height is minus 5. So therefore, the area is minus 5 into width is how much? 2. So it is a rectangle. So I can say all the way it is equal to minus 10 into 10 to the power of minus 3, right? So I'm not writing what is the units, because units you are multiplying volt and seconds. So it will be volt second would be naturally the area here, volt second, and this is volt second. Clear? That is not V minus S. This is V into S, volt into second. And A3 would be what? A3 can be written as, again, the height is going to be 5 volt and the width is how much? 8, correct? Width is 8. So how can I write this one? Height is 5 and the width is 8. So all put together it is going to be equal to 40 into 10 to the power of minus 3 volt into second. Relax. Now come back to here, and what is the total time period here? Total time period is how much? So from here to here 10 seconds, right? 10 milliseconds, and here to here 2 millisecond, and here to here again it is 8 millisecond, right? So all together how much it is going to be? So I can say 10 millisecond plus 2 millisecond plus 8 millisecond. Without any confusion, I could say this as a 20 millisecond here. Clear? 20 millisecond is the right answer for this one. Then what is going to be the average value now? Average value is equal to how much here? So 50 minus 10 plus 50 minus 10 plus 40, right? Of course, into 10 power minus 3, that is the area, divided by, we have like 20 into 10 to the power of minus 3. And if you solve this, you will going to get 4 volt, which already Sai has informed me long back. Okay, guys, those who are doing very fast, I appreciate from the bottom of the heart, but I sincerely advise the other students also make it very fast. This is a simple question. Answer is 4 volt. Clear? Answer is 4 volt. Now suppose if someone gives a question like this, okay, if someone is given like the PMMC is trying to measure the voltage signal V of t as equal to 5 into sine 100t. Tell me what is the reading. If you give this voltage to the PMMC, what would be the reading of the PMMC? What would be the reading of the PMMC? Everyone must answer here. Don't neglect this and don't be overconfident. I need the answer from everyone. So please let me know what is the correct answer for this question, guys. Everyone. Very good. So if you give this sinusoidal signal, this is a pure sinusoidal signal. What is the average value of this? Average value is 0 volt. This will be the indication of the PMMC. This will be the indication of the PMMC. Suppose instead of this, if at all you have given something like this. So please see here. This is also good question. Next one also good question. Just imagine that I have given 5 volt plus 5 into sine 100 into t, right? So instead of 5, let me take this as a 6 here. Okay, let me take this as a 6. Now tell me what is going to be the output of the signal now. What would be the average value of this signal now? Fatafat, every one of you. I need the answer from every one of you in the comment section, and I encourage every one of you, put down your pen on the paper, use the calculator and use your brain and recap your concepts, revise well and then answer here. So what is the average value here? Fast guys. The average value is nothing but the DC signal present here. So in the signal, the DC component is this. So therefore the average value is straight away equal to 5 volt here. Clear? simple. So every time it will look at the DC value present in the component, right? Now let me tell you one more important thing. As far as PMMC is considered during the deflection phase, okay, so when you are using the PMMC as a deflection instrument, probably you all might be knowing that the deflection torque TD, deflecting torque TD in PMMC could be written as equal to number of turns into strength of the magnetic field into area of cross section of the coil into the current whichever is flowing through the coil. Clear? The current which is flowing through the coil. Sir, what is RMS value of the waveform? Ashok, we will learn that. Anyway, the next concept is moving iron instrument. There I will explain. Don't worry about that. Be with me. That is more than sufficient. You will get everything what you want. So the deflecting torque is equal to N. What is N? Number of turns of the coil. What is B? B is nothing but area of cross section of the coil. And B is the strength of magnetic field. And A is nothing but area of cross section of the coil. And I is the current that is flowing through the coil in permanent magnet moving coil. And TD is considered as a deflecting torque. Clear? So this is called as a deflecting torque. Probably you all might be knowing that in PMMC, controlling torque is provided by the spring, which is equal to K into theta, and this is called as a controlling torque, right? So you might also study this point clearly, especially in a PMMC at steady state. What happens at steady state? Have you remembered, guys? At steady state, controlling torque would be equal to deflecting torque, right? So therefore, K into theta must be equal to N into B into A. Of course, this will be multiplied by I. And if you go ahead, theta will be equal to N into B into A divided by K, where K is the spring constant. I repeat, K is the spring constant into I. This is the equation for the deflection of the meter for any current that is flowing through the PMMC. Specifically, the current must be a DC quantity. Clear? Current must be a DC quantity. So please do keep these points in your mind. And I cannot tell you once again that N is the number of turns and B is the strength of magnetic field. A is nothing but area of cross section of the coil, and I is nothing but the current that is flowing through the coil. Clear? So well, now let's move on to the extension of the PMMC. See, specifically the PMMC is used as ammeter and voltmeter. We can use the PMMC as ammeter as well as voltmeter. That means we can take the same meter to measure both the current as well as voltage. When you are measuring the current, we will keep the PMMC in series in the line where we are planning to measure the current, and when we are measuring the voltage, we will connect the voltmeter across the load where we are planning to measure the voltage. Clear? So let's move ahead. Right, so let me directly take this question and answer this. A 10 milliampere ammeter has an internal resistance of 100 ohm. So first of all, try to understand this. So every meter has a specification. He himself is saying that it is an ammeter with a full scale capacity of 10 milliampere, has the internal resistance of 100 meter. Always try to keep this in your mind. The PMMC, electrical equivalent of PMMC would be like this. It is a simple meter resistance. This is electrical equivalent of PMMC. And a small indication, here it would be mentioned as 0 to IFST. What is that IFST? 10 milliampere. This is 0 to 10 milliampere. Okay, 0 to 10 milliampere. So whatever I have given here, this is considered as a permanent magnet moving coil. It is an electrical equivalent of the permanent magnet moving coil. I repeat, this is considered as an electrical equivalent of the permanent magnet moving coil. Please do keep this in the mind. Okay. And what is the value of the current resistance here? Resistance is going to be 10 milliampere. So sorry. Resistance is 100 ohm. I'm extremely sorry. Resistance is going to be 100 ohm. Just let me give 1 second. Yes, 100 ohm. Now I have a simple question to you. Can you please tell me, if you have this as a meter capacity or meter reading, what would be the maximum full scale current that can be flowing through this one? What is the maximum capacity of this meter, or what would be the maximum current that this meter can allow through it? I repeat, previously we have seen that there is an equation clearly that, once again, right. Right. So just look at this one, every one of you. Here we have seen that in PMMC current will be flowing. Based on the amount of current, we are going to get a deflection. Fine. Now I am asking a question here. According to the data, whichever is mentioned here, what would be the maximum current that can be flowing in PMMC here? Why no one is answering? Paish Kumar and Kumari and Raghuram, Sai, what would be the maximum current that can be flowing through this one? That is nothing but this. Clear? So 10 milliampere is the maximum value of the current that can flow through this particular meter at its best. At its best, right? But see, we want to measure for extending this its range to measure 10 ampere current. What does it mean? Now we need to measure 10 ampere current. But meter is saying that no, I can't measure 10 ampere. I can measure only 10 milliampere. But you are asking the meter, no, you must measure 10 ampere. Then what will going to happen? Just imagine that. Suppose if I connect directly a 10 ampere line here. So just assume that I am connecting a 10 ampere line. If I connect a 10 ampere line, what will happen? 10 ampere is far more than full scale deflection current, maximum capacity of the meter. So when the current is going through the meter, which is of maximum than its capacity, then the meter gets burned, the coil get burnt, right? So that means coil will be damaged, right? This is the reason why what people do is, don't do this kind of nonsense here, right? Don't allow very high current into the meter. Better first keep one shunt resistance here. So let us say a shunt resistance I will keep here. There is an important concept, so please read. I know there is a formula, but I want you to understand the concept before applying the formula directly, okay? So please see, R shunt. Now the crazy part of this is, look at that. Now 10 milliampere current, 10 ampere current you must send here, right? So 10 milliampere means 10 into 10 power, how many amperes here? So 10 milliampere could be written as 10 milliampere can be written as 0.01 ampere here. So that means the maximum capacity to the meter side is only 0.01 ampere. But 10 ampere we need to measure. What happens? The remaining 9.99 ampere current should flow through the shunt. Remaining 9.99 ampere must flow through the shunt. Then only 9.99 plus 0.01 all put together you can measure 10 ampere current. This is the logic behind the question. But how do we evaluate the shunt resistance? What is the value of the shunt resistance? That is the question naturally. So if you want that, you can equate the voltage, right? So now I can say the shunt resistance and the meter resistance both are connected in parallel. Shunt resistance and meter resistance both are connected in parallel. Therefore, what should I write here now? Look at that. What should I write? So the shunt resistance, voltage across the shunt and the voltage across the meter both must be same here. So voltage across the shunt is how much? 9.99 ampere it should take into shunt resistance, I would say. That must be equal to, any idea from your side? Any answer from your side? So right side, meter resistance, meter voltage, how much? Maximum current that is flowing through the meter, 0.01 into the meter resistance Rm here. Clear? So therefore shunt resistance could be given as equal to 0.01 into meter resistance is 100 divided by 9.99 here. So if you solve this, then you will going to get the shunt resistance here. Clear? You will get the shunt resistance. What would be the shunt resistance? 0.01. Lot of students are giving like this. So let me check whether that is correct or not. Divided by 9.99. So all put together it will come 0. I am getting 0.1. How does it is possible? 0.01 into 100 divided by 9.99. Guys, I am getting 0.1. Please check it where it went wrong. 9.99. That is also correct. 9.99. Everything is correct only, right? 0.1. Yes, correct. So I don't know how you guys are doing mistake. It is a 0.1. 0.1 ohm. Please do the calculation properly and let me know what is the correct answer. Right? 0.1 amp. Very good, Ashok. That's what will happen. Sometimes if you use the formulas blindly, this is what will going to happen. The accurate answer is 0.1. The voltage across the shunt, voltage across the meter, both must be same. That is the final conclusion of the whole theory here. Clear? So now let's move one step ahead and go through the concepts so detailed manner. So what else I want to tell you here is, please try to keep focusing here. Yes. So there is a formula, that is shunt resistance can be directly written as meter resistance divided by M minus 1. This is a formula, most of the students they use this, right? And while you are calculating M is considered to be how much you want to extend here, okay? So the required extension divided by the full scale value of this meter, full scale capacity of the meter. Clear? So in this case, what is the M value? M value would be written in this case as a 10 divided by, it is going to be 10 milliampere. 10 milliampere means 0.01 here. So M is 1000 here. So please try to keep here in the mind. M is 1000. 1000 minus 1, 999. Yes, that's perfect, right? Yes. All put together, either you can use this formula or you can use this calculation, whichever is fine, you can go with that. But I want to ask a question. What is the relation between the shunt resistance and meter resistance? Any one of you? What is the relation between shunt resistance and meter resistance? Which must be high, which must be low? Shunt resistance and meter resistance, which is high, which is low? Everyone should answer here. Don't simply just look, see like that. Okay. I would be saying that here shunt resistance should be always less than meter resistance. Do you know what is the logic behind this? The logic is the shunt resistance should take more amount of the current compared to the meter. Therefore, the shunt resistance must be less than the meter resistance, right? The shunt resistance must be less than meter resistance because the shunt should take more current compared to the meter. Clear? Very good, very good, very good. So that means after calculating the shunt resistance, once again cross check whether that is less than meter resistance or not, then you will get confident. However, no one can say that you are correct, but there is a probability that you are correct. Clear? Right, good. Now next one is voltmeter. So that means now let us take the same PMMC meter, which is of 0 to 10 milliampere ammeter, has an internal resistance of 100 ohm. Once again same question, but the different approach. Right? For extending its range to measure 10 volt, what value of the resistance must be connected in series? This is also a good question. Clear? So for this, first of all, let us see, right? Let us see our meter here. First of all, our meter, our meter, let me say, this is our meter here, and RM is going to be 100 milliampere, sorry 100 ohm, and this is going to be 0 to 10 milliampere current. Now first of all, if you have only this as a meter, can you tell me what is the full scale current that can flow here? Full scale current IFSD that can flow here is 0.01 ampere, which is nothing but 10 milliampere only, right? So this is 0.01 milliampere. If it is a full scale current, can you tell me what is the full scale voltage here? What might be the best voltage the meter can measure here? The best voltage the meter can measure, or the highest voltage the meter can measure, is RM into IFSD. Clear? RM into IFSD. Meter resistance is 100 ohm and IFSD could be given as 0.01. All put together, this is equal to 1 volt. Clear? That means at best meter can measure only 1 volt, right? So therefore, let me take one step privilege here and write down like this, right? So therefore, I would be writing this as, so please see here, and here plus or minus, right? Plus or minus, and what is the voltage across this? This would be given as 1 volt here, no doubt about that. This is simple. Now on which of these we must connect a series resistance here? First of all, why do we really require to connect the series resistance here? Because we require to measure 10 volt, and 10 volt is more than 1 volt, because what you want to measure is more than, okay? How damping torque helps to get the correct reading in PMMC meter? Anandiya Bose, just give me 5 minutes of time, let me complete this, and after that I will come back, right? So 10 volt. 10 volt is greater than 1 volt. First of all, you must notice this fact, 10 volt is greater than 1 volt, correct or not? So if 10 volt is greater than 1 volt, if you directly measure 10 volt here, again more current will flow through the meter. That is the reason why we require a series resistance here. Okay, so let us say there is a series resistance here. There is a series resistance, and now by including the series resistance here, we are required to measure how much voltage now? So look at that. Now this is considered as the total meter. Yes, now we can measure, or we are forced to measure 10 volt voltage. correct, 10 volt voltage. Now if you want to measure 10 volt, maximum it can take only 1 volt. Out of 10 volt, maximum it can take only 1 volt, maximum 1 volt. Then if that is the case, how much voltage you can accommodate across the series resistance now? Plus and minus. I am very sure 9 volt you can accommodate, or you should accommodate across the series resistors. Then only this 9 volt plus 1 volt altogether it will become 10 volt. That means series resistance must deliver a voltage drop of 9 volt. So anyway, series resistance and meter resistance both are connected in series only. That's why it is called as a series resistance. Therefore, I can say the current that is flowing through the meter also could be given as IFSD only. So let us say this is IFSD only. Same current will be flowing through the meter also and series resistance also. Then from these, by using the minimum common sense of circuit theory, I can say the voltage drop across the series resistance equal to what? Voltage drop across the series resistance, that is 9 volt, must be equal to the full scale deflection current into series resistance. Relax, full scale deflection current into series resistance here, right? Very good, excellent. So full scale deflection current is how much here? Anything guys? 10 milliampere. 10 milliampere means 0.01 into series resistance is how much? Series resistance we need to calculate, right? So series resistance divided by 9, and I am very sure from here RSC will come like 900 ohm here. Clear? So this is 900 ohm. Simple, right? RSC is equal to 900 ohm. So I have clearly explained the procedure also, right? First we will be calculating the voltage across this, and then we will be seeing what is our requirement. Remaining voltage has to be across the series resistance, and then follow these footprints, you will get the answer. Answer to this question is 900 ohm. However, some students are very interested to use the formula. Yes, you can use the formula here. What would be the formula here? So the series resistance, what you want to add here, that must be equal to the meter. One second. The formula here is M minus 1 into meter resistance, right? So in case of extending the current range, we must use RM divided by M minus 1. Here it is a multiplication. Okay, again M is going to be what? How much voltage you want to measure? Divided by the maximum full scale deflection. Clear? That's the whole point of the discussion. I hope I have conveyed the message here, right? So there is one question from Anindya Bose. Okay, let's come back to this one. Okay, right. So Anindya Bose, are you asking this question in terms of physical way or in terms of mathematical way? Well, I think next question it will come anyway, right? So your damping concept will come now. So please try to see here, all of you. There is one good question. I would like to explain this. Anindya Bose, please be in the comment section and respond to me. Okay. So the PMMC ammeter shown in the figure has a range of 0 to 3 milliampere. Fine. 0 to 3 milliampere current. When the switch S1 is opened, so that means when the switch S1 is opened, it is passing a current of 0 to 3 milliampere. The pointer of the ammeter swings to the 1 milliampere mark and returns and settles at 0.9 milliampere. The meter resistance is dash. So we require to find what is RM here. Clear? What is RM value? This is a very physical way. Okay, Anindya Bose. Right, then obviously I will take some time to explain, but before that let us solve this question. In this question also you will going to understand. I think I forgot to give the voltage here. Let's take 2 volt here for time being. Okay, 2 volt here. Now read the question statement and try to get it in the way. So what we can do here, so there are 4 options here, and read the options also, then you will get some brilliant explanation here. So please see, there are 4 options. Out of 4 options we need to calculate one. So first of all, what it was said, the PMMC ammeter shown in the figure has a range of 0 to 3 milliampere when S1 is opened. The pointer of the ammeter swings to 1 milliampere and returns and settled at 0.9 milliampere. The meter resistance is dash. So have you understood here, particularly in this case, right? So theta, right? Time, 1 second. Time. All of you should answer to me now. Now the current reading I. Just see what he was saying is PMMC is used to measure the current here. Why? Because it is an ammeter. It is simply an ammeter. And he is saying that when the switch is opened, the overall current will be flowing through the load resistor only, 1.8 kilo ohm only. At that time, the ammeter is ready to measure the current. Now, can you tell me, suppose if the switch is closed, if the switch is closed, what would be the current that is flowing through the ammeter? Any one of you? If the switch is closed, the current flowing through the ammeter is 0. If the switch is open, then only the current can flow through the ammeter. Very easy to understand, right? And according to the question, he is saying that the current is jumping to, the meter reading is jumping to 1 milliampere and then again oscillating and then finally settled at 0.9 milliampere. So that means, what is this here? So any one of you? Is it the second order instrument or first order instrument? So I can say it is settled at 0.9 milliampere. However, the peak value is going to be 1 milliampere. So that means it is swinging to 1 milliampere and returns and settles at 0.9 milliampere. What is this? This is the second order graph or first order graph. What is this? It is the second order underdamped system, correct? This is the second order underdamped system. That means damping is naturally built. Damping is naturally built in the PMMC construction. Clear? In the PMMC construction. This is the second order and however, the final value or the steady state value of the current is 0.9 milliampere. That means finally the meter will show only 0.9 milliampere. Finally the meter should show 0.9 milliampere, right? So that what happens here is, one second, what is the meter current here? So we know this meter, ammeter will also have some resistance Rm here. So I is equal to 2 volt in the loop, 2 volt divided by Rm plus 1.8 kilo ohm. Clear? 1.8 kilo ohm. So therefore, anyway, 1.8 kilo ohm only you will going to have, right? So therefore, I could be written as 2 volt divided by Rm plus 1.8 into 10 to the power of 3, right? So can you please tell me for time being, what is the value of this resistance? 0.9 into 10 power minus 3. Guys, please do fast and tell me what is the value of Rm here. I am waiting for your answer. What is Rm? What is Rm? Anyway, meanwhile, I would say this is the second order underdamped system. Second order underdamped system. Underdamped system. Yes. Can we say it as second order instrument? Yes, Anandiya boss, it is a second order instrument only. PMMC is a second order instrument only. Okay. Now, Anandiya boss, listen to my explanation because you have asked one question, right? Physical way of providing the damping. In PMMC, when we pass the current, what happens? The coil is winded on a soft iron piece, right? So we have two magnetic poles here, North Pole and South Pole. In between the North Pole and South Pole, we have a cylindrical soft iron core, right? So on which you are having the coil. What happens is when the current is flowing through the coil, then it creates a deflecting torque. All the way the coil rotates like this. When the deflecting torque is developing inside the coil, equally the controlling torque also gets developed in the spring. At steady state, controlling torque will be equal to deflecting torque. That is what we are studying. But what happens in reality is, you will have one more torque which is called as a damping torque, which act opposite to the deflecting torque. Suppose let us say we have a coil like this and the current is flowing inside the coil in the upward direction. Current is flowing inside the coil upward direction, and because of that you are getting this kind of rotation. But do you know one thing? When the conductor is rotating inside the magnetic flux, back EMF will develop, and that back EMF creates the eddy current. So the eddy current will actually flow in the reverse side of the actual current. That means actual current to be measured if it is flowing in the upward direction in the coil, eddy current will actually move in the downward direction, which is reverse to the original current. So that will create opposite torque to the deflecting torque. Because when the current direction of the eddy current is reverse to the actual current may ask the coil to rotate in this way, but the eddy current will ask the coil to rotate in this way. So likewise, the counter torque will be provided because of the rotation of the coil inside the magnetic field, and that will provide the damping. I hope I have conveyed the message very clearly to you, Anandiya boss. In PMMC, the damping torque is the reality and it is possible because of the eddy current. Okay, eddy current, right? So, fine. Actually, take this as a 1 volt. Guys, please take this as 1 volt for me. Just take this as 1 volt. Instead of 2, take this as 1 volt. Because I didn't remember what is the voltage. Anandya boss, please let me know. Is it clear to you or not? Anandya boss, I have explained so much for you only. So please let me know. If you take 1 volt, what would be the answer here? 1.8 kilo ohm, it was said as 1. Guys, if I take 1 volt, what would be the answer? Just take this as 1 volt and tell me what is the answer here. Otherwise, you can do like this. So, just give me 1 second. 1 divided by 0.9 into 10 to the power of 3, 10 power minus 3, that is equal to Rm plus 1.8 kilo ohm, 1.8 into 10 to the power of 3 here. Here. So, what is this value? 1 divided by 0.9. Correct. Perfect, Anandya boss. Excellent. Excellent. Whatever you said is correct. Perfectly all right. I think you got the point now. Okay. So, guys, I think let us go with, yeah. That is wrong answer. So, I think seriously speaking, 1 second. Let's go with the 2 only, because otherwise we don't get proper reading. Calculate what is the value of Rm here. But my suggestion is, here the value of voltage is mixing. So I took randomly that as 2 volt. That's why none of the answer may match with this. Okay, none of the answer, because none of the answer may not match with this because I took this voltage. You go to the question, previous year question, and look at what is the actual voltage here and solve this, then you will going to get an accurate answer. That is my responsibility. But let's consider 2, as it is missing. I have taken this as a 2 volt, and if you take that as a 2 volt, you will get some value of Rm. Already every one of you calculated here. But what is most important out of this question is, it is a second order underdamped system. Hope it's very clear to all of you. Guys, shall we move to the next question now? Next question is, right, moving iron instrument. Wow, fantastic. Right, before going to moving iron instrument, right, anyway we'll solve this question, but I just want to tell you the basics that are required here in 1 second. So, moving iron instrument, it is a RMS meter. It is RMS meter. RMS meter means it is capable of measuring both DC and AC also. It is capable to measure both DC and AC. But we mainly use RMS meters to measure AC quantity. Clear? And remember this point. When I say RMS quantity, it is going to measure only RMS value of the signal. Okay? So please keep this in the mind. Now moving ahead. In this case, what is the deflecting torque formula here? Deflecting torque formula is equal to half into I square. That is, if it is a DC quantity. If it is AC, then IRMS you need to write here. This is IRMS. Okay, I stands for IRMS in case of moving iron instrument. Okay, into dl by d theta, where L is nothing but the self-inductance of the moving iron vein here. Clear? So this is deflecting torque. However, the controlling torque could be simply given as K into theta, and at steady state we don't require the damping mechanism. So at steady state, I think Anandya Bose, I have explained the concept so clearly to you. You might be really very happy, right? So please let me know in the comment section, have you enjoyed the explanation? So TC is equal to TD. Therefore, I could say K into theta is equal to 1 by 2 into I square into dl by d theta. Clear? So from here, the deflection could be written as 1 by 2K, that is a spring constant, into I square into dl by d theta. So please keep this in the mind and try to keep one more information here, that is theta is directly proportional to I square. So if it is a AC signal, this is IRMS square. Clear? Right. IRMS square. Yes, mid frequency signal, not comparable for high frequency measure. Yes, perfect. Anindya, perfect. Because when we go for high frequency measurement with the moving iron instrument, the setup is very small and the components what we use cannot tolerate at high frequency. You will get a lot of error. Okay, so it is a non-linear device. Unlike it is a non-linear instrument. Unlike PMMC, moving iron is a non-linear instrument. Clear? Number one. And now let's see how we can approach this. But before going to that, K is considered as a what? K is considered as a spring constant. And I is IRMS. Again I am saying that IRMS. Don't take the peak value if the signal is given. Okay, it is the IRMS value. Multiple times I am explaining the same point, means there is a lot of significance for that, and most of the students they commit the mistake. That's why. Clear? Now let's move on to the next one here. Yes. Oh, there is one question here. So let me finish it. This answer is already mentioned. The inductance of a certain moving iron instrument with a full scale deflection. One second, let me take. With a full scale deflection 90 degrees, okay, at 1.5 ampere is expressed as L equals to 200 plus 40 theta minus 4 theta square minus theta cube microhenry, where theta is the deflection in radian from 0 position. The angular deflection of the pointer for a current of 1 ampere will be how much? Clear? 1 ampere will be how much? Sir, in the middle few seconds rainbow is coming. Yeah, I understood guys. Actually there is some connecting issue here. Later, but today try to cooperate with me. Let's finish it. Whatever the technical issues are there, I am extremely sorry for the inconvenience, and we will rectify for the next session. But for this session please bear me. Okay, right. So here first thing he is saying that when the current is equals to 1.5 ampere, this is case 1. Let me take this as a case 1. Okay, let us take this as a case 1. If anyone completes this, you can post the answer here. I will be at most happy to see the answer from your side. Case 1. So look at that. So if theta is equal to 90 degrees, one second. The current what is flowing here, the current what is flowing here is 1.5 ampere, and this is making the deflection 90 degrees. 90 degrees kaisa likhega? So theta 90 degrees means it is going to be pi by 2 radian. Clear? Theta is equal to pi by 2 radian, right? Now relax. Theta is equal to pi by 2 radian. 90 degrees means pi by 2. Now if this is the case, because the spring constant is not given, what was the formula we have studied? Theta is equal to 1 by 2k into I square dl by d theta. So therefore I can say theta is equal to 1 divided by 2k into I square 1.5 whole square into dl by d theta. Correct? dl by d theta. So look at that. What is the dl by d theta? If you take dl by d theta from here, what is dl by d theta? Simple. Look at that, 200 will be out. You are going to have only 40 here, minus 8 times of theta here, no doubt about that, minus 3 times of theta square here, 3 times of theta square into 10 to the power of minus 6 you will going to have, because it's a microhenry, right? Now substitute here 40 minus 8 into theta minus 3 theta square. Of course I told you that you will be having 10 to the power of minus 6 here, 10 to the power of minus 6. Please don't miss that one. 10 to the power of minus 6 also there here. The 10 to the power of minus 6 is there at the end. And now theta value we can keep. What is the theta value here? So look at the theta value. So theta value he is saying 90 degrees. So it is pi by 2 here. So let me put this as a pi by 2 here. And we require to get one spring constant. So into 1.5 square. So I am very happy to see what is the value here. 1.5 square. 1.5 square. Guys, if you have completed, so please let me know the answer in the comment section. 40 minus 8 into pi by 2. So 8 into pi by 2 minus theta 3 into pi by 2 whole square. So 3 pi square by 4 into 10 to the power of minus 6 here. Do slowly and tell me what is the value of k out of it. So I am waiting for your k, and take your pen and paper and do for the value of k here. Do for the value of k. So we'll do one thing. This math I hope you can do this even in your home also. Once you get the value of k, you will be getting some value for the spring coefficient. I'm very sure about that. You will get some value of K. But again, what was the question they're asking now? Now look at the question again. The question is, what would be the angular deflection again of the pointer for a current of 1 ampere? Next time, case 2, they are sending a current of 1 ampere and they are asking what is going to be the deflection. Again in case 2. So let me write here case 2 of that, case 2 of previous question. So let me write down previous question. What should I say? Theta is equals to 1 divided by 2 times of K here, right? Into I square, now current is 1 ampere, I square into dl by d theta. What is dl by d theta? dl by d theta already know, that is 40 minus 8 times of theta minus 3 times of theta square microhenry into 10 to the power of minus 6. Clear? Now in the case 2, what we require to calculate? Because K is calculated now. How do you get the value of K? Already we got the value of K here. Get the value of K. Once you get the value of K, substitute here and evaluate for theta. It takes some time, but you will get the correct answer. Okay. So get the value of K, get the value of theta, and that will be your final answer. Clear? So that means first, once you get the value of K from the case 1, substitute the value of K in the second case to get the value of theta. But in the first case, when you are doing, you are using 1.5 ampere as per the data, and second case you are using 1 ampere again as per the data. See guys, you must be very clear about the data. If you are not so clear about the data and not so clear about the concept, nobody can help you. Clear? I hope I have conveyed the point very clearly to you. Now that calculation part, I am very sure you all are capable. If I am struggling in calculation, if I am doing minute calculation, then I may not be able to explain the major concepts. Okay. Whenever a small calculation comes, you please take care about that, because you are very capable of doing that. I am capable of teaching very deep concepts, right? So let's go with that. So if a current of, so this is current waveform, I of t, that is flowing through a ampere, is passed through the true RMS meter, means moving iron meter. The meter reading will be dash. This is exactly I told you earlier. Suppose if this kind of current is given, so look at that. I of t is equal to I1 of t plus I2 of t plus I3 of t. So on, if you have a lot of signals in your sinusoidal, in the current, then IRMS can be written as, IRMS is the reading, that must be given as under root of, look at that, IRMS of the first signal, I1 RMS square. Once again, I1 comma RMS square here plus I2 comma RMS square here plus I3 comma RMS square here, and continues like that. Clear? So because this is a composite signal, I hope you are very clear about this composite signal. Now what is I1 of t here? I1 of t is this, I2 of t is this, and I3 of t is this. Clear? So for this signal alone, what is the RMS value now? The RMS value of this signal, let us say I1 comma RMS, which is equal to peak value by root 2. So peak value is minus 6 by root 2. RMS, anyway, peak value by root 2 you will be having. So Vm by root 2. So it will be minus 6 here. Simple, right? So and again, what is the RMS value of this one? RMS value of this also same, I2 comma RMS. Right, so this is the second signal, RMS value is 6 root 2, Vm by root 2, peak value is 6 root 2 divided by root 2, it is going to be 6 here, and this is the third one, right? So I would be saying this is the third one. I can even say that is I3 RMS would be equal to 6 root 2 divided by root 2. Of course, this is going to be 6 here. Clear? So this is again 6. I hope all the RMS value, sorry, I am extremely sorry guys, very extremely sorry. This is a DC signal, right? So if it is a DC signal, its RMS is same. Its RMS value, DC signal ka RMS same hai na? So pure DC signal, I3 RMS could be written as 6 root 2 only. No need to do anything. That is 6 root 2 only. Then we can say clearly, as we have only 3 signals here, this etc. is not required here. Not required here. Let's take all the values here conveniently. So therefore I could say under root of yes, minus 6 whole square here plus 6 whole square here, and then again 6 root 2 whole square here. All put together, I am very sure that this is 36 plus 72. So 36 plus I think you will going to have 4 times of 36. 4 times of 36, yes, 144 if I am not wrong, right? 144, and it will going to be equal to 12 ampere. 12 ampere is the correct answer for this question. Raghu, what happened? You have mentioned the wrong answer earlier. Be very good with the calculation. Okay, what happens is you have studied all the concept by paying a lot of attention and a lot of hard work from last 1 year, probably most of you. In the examination time, if you do a small calculation mistake, after the exam, when you refer the solution, if you find that yes, you have committed a small mistake, trust me, that will disturb next 1 year till you get placed in one of the good position. Okay, so if you do mistake because you don't know the concept, that is okay, understandable. But if you do calculation mistake at this point of time, right, so then it really hurts a lot when you complete your exam. Please mind this one and be careful also. Okay, Raghu, this is for you only. Right, 12 ampere, take this as a suggestion. It's not a warning to anyone, because I am not in a position to give warnings to anyone. Right, so moving iron instrument, extension of ranges. So same thing, in case of moving iron instrument, what we do is, so yeah, if you use the meter means, now it will have inductance and resistance. Electrical equivalent of the meter. So electrical equivalent of the meter, especially for, you know, this LM and RM. This is called as a moving iron meter. This is the electrical equivalent. Yes. So this is electrical equivalent of moving iron instrument. Hope you remember that in case of PMMC, we will not have inductance of the coil. But here inductance plays a dominant role. That's why we use this inductance. Clear? Now relax. Now, if you want to extend its reading as an ammeter, then we will have to connect a shunt coil for this. Clear? So every time when we want to extend, we want to measure more amount of current, then naturally we must give, this is I, and I could say the maximum current that it can handle, IFSD, and now we must have a shunt coil here. Shunt coil, so naturally we will be writing, this is the shunt coil, so that is LSH and RSH. Clear? RHS. Right? Now the most important point here is, whenever you write shunt coil here, shunt current, I shunt would be written like this, I shunt. Clear? Now one thing I can say, the value of the voltage, is it possible to write like this? Shunt current into the impedance of the Z shunt, that must be equal to full scale current, whatever we are seeing here, into full scale current into, what should I say here? This is going to be the meter shunt, right? So meter impedance. Therefore, the shunt current, whatever we are taking out by the full scale current IFSD, would be written here as equal to meter impedance Zm divided by shunt impedance. And meter impedance divided by shunt impedance could also be written like this. Meter impedance is nothing but Rm square plus omega into Lm whole square divided by the shunt resistance square RSH square plus omega into L shunt square. Relax. Then still I can say shunt resistance by IFSD, it would be equal to, take Rm outside, then Rm by R shunt all the way. This could be written as equal to 1 plus omega into Lm divided by Rm here whole square divided by 1 plus omega L shunt divided by R shunt whole square. Clear? Whole square. And please try to, Das, how are you? Good morning. It is almost afternoon. We are about to, we are almost in the middle of the subject. Okay. So this is considered now as the time constant of the meter. And this is considered as the time constant of the shunt coil. Time constant of the shunt coil. Clear? Now what we do is, we successfully try to make, especially in moving iron meter, we will try to make the time constant of the shunt, please try to see time constant of the shunt coil. If time constant of the shunt coil is equal to time constant of the meter, then I can neglect these two, right? Then it will become a frequency independent, and we will be having Rm divided by R shunt here. Clear? Rm plus R shunt. Understood? So this ratio will become frequency independent only when time constant of the shunt coil and time constant of the meter both are same, and that itself it is one of the very good question. But what is the relation between ISH and IFSD? Simple. Every time it is same. So please see here, I would be written always as shunt current plus meter current. This will be given to you and this will be given to you, right? And anyway you require to calculate this. If you don't require to calculate, we can take, you know, I shunt you can remove like this also. I minus I shunt, that would be considered as IM. Sorry, you require I shunt, right? So I minus IM, this would be considered as a shunt current. This current directly we can use here, replace here, then what you will going to get? So wherever ISH is there, I minus IM will be there, IM or IFSD. Instead, just give me like this, instead of this, for full scale current, it will become IFSD. Hope I have conveyed the message here. So from this value, I is known to you because it will be given in the question. IFSD is also known to you because it will also be given to you. And if you take the difference between these two, you will have I shunt. Take the I shunt value here, keep I shunt, and IFSD is known to you. If you take this ratio, then meter resistance will be given to you. Only the shunt resistance you should calculate. But you can use this formula only when the time constant of the shunt coil equal to time constant of the meter here. Otherwise, you cannot do that simple calculation here. Clear? So because everything will become frequency dependent. Now guys, I want a reply from every one of you. It is almost around 1.5 hour session. So please let me know, are you aligned to me or not? Are you energetic or not? Are you in line with the explanation or not? Any doubts so far? Please let me know in the comment section. I know that the frame is the tilting, but please bear about the technical issues. But let me know in the comment section, is it clear everything so far or not? Fast. Yes. Only Raghu is saying, or Raghu is saying very fast. Where is Anandi Bose and Mohan Sai? Good, very good. And Payash Kumari and Lokesh Gotapu. Who else are there here? Anandi Bose is there. Very good. Yes, sir. Understanding. Good. So let me go ahead to the next one, that is wattmeter. Wattmeter and energy meter I will complete. After that, we'll take 5 minutes of quick break and then continue. Otherwise, if you don't want the break, we'll continue and complete it. No, everything is in your hand. Two types of connections of wattmeter. See, wattmeter is specially used for the power measurement. It can be of DC or it can be of AC, anything, power measurement. So, pressure coil are shown in the figure. The value of the wattmeter current coil resistance, which makes the connection of the error, is same in both the cases. So this is the basically the application of electrodynamometer. Application of electrodynamometer. Okay, I think there is missing here. So it is a load voltage is 200 volt. Right. So this is the application of electrodynamometer. Okay. So in wattmeter, see ultimately what is the purpose of wattmeter? We need to measure the power. Whose power? Power across a load. So how do we measure the power across the load? So look at this, power across the load could be written as the current that is flowing through the load into voltage across the load. Correct? Current that is flowing through the load into voltage across the load. So to measure the current that is flowing through the load, we use current coil like this. So this CC means current coil. And what it is doing, it is the main intention of this current coil is to measure, okay, current flowing through the load, right? And VL is actually nothing but the voltage across the load. To measure the voltage across the load, we use potential coil here or pressure coil here. So this total setup is together, it is called as a pressure coil. This total is considered as a pressure coil. Ideally, what should happen? Ideally, current coil should indicate only the current flowing through the load, and pressure coil should measure the voltage across the load. This is a fundamental logic. Okay. Now look at this in this particular case, in the first case. So I repeat once again. Right. So in this case, suppose if we are having the error here, so assume that the current coil resistance RC, okay, is not equal to 0 ohm. There is some resistance, right? Then what would be the voltage indicated here? Now the voltage indicated would be given as voltage indicated by the voltmeter PC could be equal to what? Voltage across this plus voltage across this, correct? Voltage across this and voltage across this. Then what will going to happen? Because of this resistance of the coil, some amount of the power will be dropped. Why? 20 ampere current is even flowing in this also, correct? So that means I am very clear about this. The error in the first connection is what? Error in the power calculation in the first case, error in case 1 equal to the error created by this current coil. Why? Ideally the current should flow only through the load, but it is also flowing through the resistance of the current coil. Then when you use the voltage measurement here, your voltage will be the summation of this plus this, which you don't want. Actually your voltage must be voltage across this. That means in this case the current coil is not ideal. I repeat, in this case the current coil is not ideal, and whatever the resistance is there, current coil, that creates some power drop, and that is considered as an error here. So load current square IL square into the resistance of this, so that is nothing but RC. Is it clear to every one of you, or please tell me yes or no? In the case 1, the error in the power reading is load current square into resistance of the current coil. Ideally, what should be the value here? Ideally, the resistance of the ammeter or the resistance of the current coil must be 0 ohm. Ideally, it should be 0 ohm. Now, in the second case, you look at that. What happens here is, whatever may be the current that is flowing here, doesn't matter. Ideally, if you are having the load current here, IL must be equal to 20 ampere. This is ideal. Load current equal to 20 ampere, ideally, right? But in this case, what happens is, because of some resistance of the potential coil, see the resistance of the pressure coil here. Because of the resistance of pressure coil, some amount of the voltage will be dropped here. Clear? Some amount of the voltage is going in this way, right? So some amount of the current will be going here, which is nothing but current through the potential coil. Ideally, the resistance of the pressure coil or potential coil must be infinite ohm. Clear? Then only there will not be any leakage of the current in the load current. There will not be any leakage in the current in the load current. Now logically you think and tell me, what would be the error in the second case? Error in the second case is created by the resistance of the pressure coil. How do we get the resistance of the pressure coil? Error in the power reading is what? Power reading is whatever the voltage that pressure coil is showing, Vp square, divided by the resistance of the pressure coil, Rp. Clear? So that means Vp square divided by Rp. Vp square divided by Rp here. Hope I have conveyed the message. Now he is saying that this error in the first case and error in the second case, both must be same here. So error in the first case and error in the second case, both must be same. So how do we write that one? Error in the first case and error in the second case, both must be same. Can you guys please let me know? So here IL square into RC, IL square into RL, and here VL square divided by RP. Clear? So this is VP or VL, that is one and all same here, because potential coil is directly connected across the load. Correct? Directly connected across the load. Therefore, what should I say? IL is 20 ampere, 20 square into current coil resistance, let me say RC here, which is equal to 200 volt is the load voltage across the load, into square divided by potential coil resistance is how much? That is 10 kilo ohm. So 10 to the power of 4. Therefore, I can say RC equal to 200 square divided by 20 square into 10 to the power of 4. Guys, first can you tell me what is the answer? Every one of you calculate it and let me know the final answer here. All of you must be very accurate and fast enough. What is the answer? 200, 10 square 100, so 10 square divided by 10 power 4, I think it is 0.01 ohm. So please check answer here, calculation, every one of you. 20 you can take inside, so it will become 10 times. So 10 square 100, 100 divided by this one, 10 square divided by 10 power 4, that is 0.01 ohm. So perfect Mohan Sai. So I think now you understood. In the first case, current coil is non-ideal. Because of the current coil, voltage will be dropped across this. Naturally, some amount of the power will be lost in the measurement. Second case, because of the resistance here, again we will going to have a power loss. So now all of you please try to understand the basics. Power measurement by the wattmeter must be equal to the load voltage into load current, RMS value of the load voltage into RMS value of the load current into cos phi. Cos phi is considered as the power factor of the load, and this is single phase. This is single phase power, single phase wattmeter. Okay, because we have only one phase here, cos phi. And usually to measure the voltage across the load, we use the potential coil or the pressure coil. To measure the current that is flowing through the load, we use the current coil, and the connection must be like this. Ideally, you need to keep these points in your mind. Ideally, what should happen here? Ideally, let's look at that. Ideally, current coil resistance, the resistance of current coil, resistance of current coil must be equal to 0 ohm. At the same time, the resistance of the pressure coil or the potential coil, pressure coil or the potential coil, that must be equal to infinity ohm. That's the whole point of the discussion, and these are the basics which are very required. And I have also shown you the connection, and I have discussed one of the popular question. Now let's look at 2 wattmeter method in 3-phase power measurement. Clear? So here it is considered as very important and holistic measurement, especially for the power measurement in 3-phase circuit. Now you see 3 phases are there, R, Y and B. 3 phases are there. So we require to calculate the power in all 3 phases. So power in a single phase is equal to this, line load voltage into load current, RMS value of the load voltage, RMS value of the load current into cos phi. Clear? So suppose if it is a single phase, instead of writing that, people do like this way. So please see here, V phase, phase voltage into phase current into cos phi. Right? So Anandi Bose is the power measurement that comes from the mutual induction between the pressure coil and current coil, which gives the quantity. Yes, perfect. Basically, Anandi Bose, it is the interaction between the current that is flowing through the pressure coil and voltage coil that develops the torque. Right? That is the basic principle of electrodynamometer. Wattmeter is constructed based on the electrodynamometer, and you are absolutely correct. Whatever you have said, that's 200% it is correct. Right? Now moving ahead to the next level, relax and look at this and tell me. Everyone must answer. It's not like that I will only look at this. So first of all, we are neutral. Okay, so just whenever you have this one, if you want to measure power in n phase, you require n-1 wattmeter minimum. I repeat, if you want to measure the power in n phase, then you require minimum of n-1 wattmeter. We require to measure the power in 3 phases, so we require to use a minimum of 2 wattmeters. Clear? So moving ahead, the very first thing what I should say is we are n, that means neutral. Please try to keep, this is considered as a neutral line, so let me call this as a neutral line here. Okay, n stands for neutral. So we are n and VBN. If it is a balanced load, then I can say we are n. One second. If it is a balanced load, then VRN and VBN and VYN, all three put together, it is called as a phase voltage. Clear? This is called as a phase voltage. And similarly, VRY and VY, if it is a balanced load, then obviously all these three are same, VYB and VRB. All these are considered as a line voltage VL. So this is called as a phase voltage, and in this case this is called as a line voltage. Okay, most of the students, they get confused whenever I write like VL. They feel that this is a, yeah, when I write like a VL, they feel that it is a load voltage. No, it is a line voltage. Clear? Now first thing, in star network, like what I have shown you, star network, your line voltage must be equal to what? Line voltage equal to √3 times of phase voltage. Clear? Line voltage is equal to √3 times of phase voltage, and most importantly, line current and phase current both are same. Clear? Line current and phase current both are same. This is number one. Number two is in one second, in delta network, what should I say? Line voltage and phase voltage both must be same. However, line current is equal to √3 times of phase current. So these points you must keep in your mind regularly as long as we move deeply into the wattmeter, and especially for instrumentation students, these are golden words. Okay, so at any cost, please don't neglect these things, because at the end of the day, everything is important. And most of the students, they feel that yes, we know all these things, but what is the need to study now? No, don't do that. Okay, so now moving ahead with the 2 wattmeter method. Okay, so still I have not done with this. So look at that, where the wattmeter 1 is connected here, the current coil of the wattmeter 1 and the pressure coil of the wattmeter 1, where it is connected. Current coil is connected all the way to take the current of IR, right? So wattmeter 1, if you are clever enough, wattmeter 1 reading I can say like this here. So please see here, wattmeter 1 reading is equal to, one second, wattmeter 1 reading is equal to the voltage of the potential coil. What is the voltage across the potential coil? It is there between R and B. R and B. Look at that. R and B. Potential coil is across R and B. So VRB, that is what I need to write, into, and the current that is flowing through the wattmeter 1, that is current coil is IR, into cos of, be careful with this, cos of the angle vector, the angle between RB and vector and IR. So this is very, very important. Clear? And at the same time, you have one more thing. And what about the wattmeter 2 reading? Relax. Wattmeter 2 reading, how do we get that? Wattmeter 2 is placed between Y and B here. Y and B here. So VYB here, right? VYB, and then again this is going to be IY here. Clear? IY. VYB into IB here, IB, into cos of angle between these two, right? So VYB phasor minus IB phasor. So please keep these points in your mind. Clear? So just give me 1 minute time. I will show you what is the angle between these two, because this is very important calculation. First of all, your 3-phase circuit. How do we write this one? RYB, right? So let me draw the circuit here. I mean, draw the phasor diagram here for time being, right? So this is going to be VR, and this is going to be what? VY, and this is going to be VB, right? So we require VRB. How do we require? How we get VRB? VRB is VR minus VB. So therefore, VR minus VB means we require minus VB first. So minus VB, if you take it, then it will become minus VB here, minus VB vector here. This is also vector here. This is also vector here, and this is also vector here. And great thing is the angle between these two is going to be 60 degrees here. Relax. Minus VB. But we require VRB. How do we get VRB here? VRB is nothing but VR minus VB. So therefore, we should consider a parallelogram theorem like this, right? So draw a parallel line to minus VB, parallel line to VR. So if you draw the parallel line to VR, then obviously it will come like this. Then this is the intersection point where I can clearly write, and without any second hesitation, that this will be your VRB. Clear? This is considered as your VRB, right? So let me take, this is a vector VRB bar. Clear? VRB. But you require the angle between VRB and IR. IR, let us say, for some time being, it is a lagging load. Okay, it is a lagging load, Z at an angle of phi, Z at an angle of phi. If it is a lagging load, that IR, the current in phase R, will lag the phase voltage by an amount of phi. Current in this phase lags the voltage by an amount of phi. So therefore, I would be saying current in VR lags the voltage by phi. So let me take another current here. Yes. So maybe IR would be taken like this. IR, let me take, this is IR for time being. Let me take, right? So this is IR. Right? So this is IR. IR. Now relax. Please try to identify all the angles here. This is a phi, lagging angle phi, correct? But have you noticed one thing? What is this angle here? From here to here, this angle is going to be 30 minus 30 degrees, right? So then what I require? I require finally the angle between, where to where? IR and VRB. So only this angle I require, correct? So this angle I require. So the angle between VR and IR is phi. The angle between VR and VRB is 30 degrees because it's bisecting 30 degrees. So here it is also going to be 30 degrees only. It is 30 degrees. Now what is the angle we require? We require this angle. So this angle would be how much? 30 minus phi. Clear? This is considered as a 30 minus phi. Therefore, W1 reading now could be written as VRB, that is the line voltage, right, into IR, it is the line current, into cos of 30 minus phi. Clear? This is 30 minus phi. Do in the similar way, and for W2, if you do the same phasor equation whatever I have told you, there you will going to get 30 plus phi. Why? You have VYB and IB. VYB, where do you get VYB here now? So can you please tell me here? So let me remove this one first of all. 30 minus phi, I feel that it's clear to you, right? So VYB means Vy minus Vb. So draw a parallel line for this and draw a parallel line for this. So therefore it is considered now as VYB. Specifically this is VYB vector, and IB we require. Where is IB here? So IB, VYB and IY or IB? IY. So this is IY. That's what I am looking at. This is IY. So just give me 1 second time. This is IY. Yes, IY. IY is lagging Vy by an amount of phi. IY because of the lagging power factor, and we know that this is going to be 30 degrees here. Now relax. Can you please tell me what is the net angle from here to here now? Net angle from here to here, this is going to be equal to how much? This is equal to 30 plus phi here. Clear? 30 plus phi. Therefore, W2 reading can be written now as line voltage VL, line current IL into cos of 30 plus phi here. 30 plus phi here. So ultimately at the end of the whole calculation, everyone who has a minimum common sense, they will understand that this is wattmeter 1 reading and this could be the wattmeter 2 reading, and VL is said as the RMS value of the line voltage, IL is said as RMS value of the line current, right? Now if you have these two wattmeter readings, how do we get the total power? So what we do is, we will take the first wattmeter reading and second wattmeter reading, and both of these we will add that. When we add that W1 plus W2, then by using that simple trigonometric rules, we will be getting this one exactly like this. Clear? This is called as the active power. Active power in all three phases, active power. And most importantly, if you write in terms of phase, so I could say that this is a √3, and wherever line voltage is there I can say √3 times of the phase voltage, very nice, into I phase into cos phi, and this will lead simply to 3 times of V phase into I phase into cos phi. That is what exactly I was saying earlier. So 3 times of this, it is a 3-phase power measurement. 3-phase power measurement means 3 times of single phase. Single phase power measurement is how much? V phase into I phase into cos phi. I repeat, single phase power measurement is V phase into I phase into cos phi. Correct? V phase into I phase into cos phi. So 3 into this means it is a 3-phase power measurement. So simple to understand. Why do you require a lot of muzzle things here? And if you take W1 minus W2, Then you will going to get VL IL, of course this should be minus here. I'm extremely sorry guys. Once again, it should be minus here, and then that will come down to be equal to VL into IL into sine phi, right? So VL into IL into, sorry, W1 minus W2, fine. Then let us take W1 minus W2 into root 3, then you will going to get root 3 into VL into IL into sine phi. So these two things are very simple. This and this both are calculated. W1 plus W2 is all the way this one. Just give me 1 second. This is W1 plus W2. Clear? And here you are going to have this as again line voltage root 3 times of, no, it's not required to do like this. So just keep like this. VL into IL into cos phi. Fine. This is W1 plus W2 and this is W1 minus W2. This is W1 minus W2 and this is W1 plus W2. Right? So in terms of line voltages, I am going ahead. Now if we want the power factor, how do we get the power factor here? After this much of hard work, power factor can be easily calculated. So just take the ratio between W1 minus W2 divided by W1 plus W2. What you will going to get here? So that is VL into IL into sine phi divided by root 3 times of VL into IL into cos phi. I am extremely happy to say that these two will get cancelled and you will going to get 1 by root 3 times of tan phi. So 1 by root 3 times of tan phi, and from there one can easily rewrite this as phi is equals to tan inverse of root 3 into W1 minus W2, of course, divided by W1 plus W2. I think I have conveyed the message clearly. Once you get the phi value, then cos phi will be your power factor. I repeat, once you get phi, then cos phi is your power factor. Such an interesting thing, right? So nothing is difficult here, only you must have patience. That's all. Now let's go to the simple question. The power in a power of a 3-wire balanced system was measured by a 2 wattmeter method. Very good. Right? The reading of the 1 wattmeter was found to be double than that of the other. What would be the power factor? Simple. So he was saying that the reading of the first wattmeter is twice than that of the second wattmeter. So that means W2 is equal to 2 times of W1, or we can say W1 is equal to 2 times of W2 because power factor will remain same. So let us say W1 is equal to 2 times of W2. What is the power factor first, guys? Tan inverse of root 3. Raghuram, you have done the mistake. It has to be root 3. Please be careful. It should be root 3. Otherwise, you will end up with the wrong answer. So W1 is equal to this. First of all, phi is equal to, I have calculated tan inverse of root 3 into W1 minus W2. Of course, that's what we have got it. So let us do one thing. W1 is equal to 2 times of W2. Fine. Here it will be W1 plus W2 here. Fine. Then it will be equal to phi is equal to tan inverse of root 3 into W1 minus W2. What is that? W1 minus W2, it will be 2W2 minus W2. So it is simply like W2 here. So 2W2 minus W2, it is W2, and 3 times of W2 here. Clear? So what you will going to get, guys, can you help me here? Tan inverse of 1 by root 3 here. So tan inverse of 1 by root 3, if I am not wrong, this is going to be how much? So 60 degrees or 30 degrees? Tan inverse of 1 by root 3, 30 degrees, right? This is going to be 30 degrees. This is nothing but sine 30 divided by cos 30. So you will going to get 30 degrees. So absolutely fine, no doubt about that. But this is not what you want. You want power factor. Power factor is equal to cos phi here. So what should I say? Cos of 30 degrees here. So make it fast. What is cos 30? Cos 30 is root 3 by 2, right? 0.866. 0.867 approximately. That is considered as a power factor. So 2 wattmeter method is used to measure 3 things. One is active power consumed by 3-phase circuit. Active power consumed by 3-phase circuit. Reactive power consumed by 3-phase circuit. Reactive power, and third is power factor. What else you want actually? You have got everything what you want in the 3-phase, right? You got everything whatever you want, because these are the three main parameters, the main variables what people expect, especially from the three-phase circuit. We got 3 out of 3. That is the reason why 2 wattmeter method is considered as a golden asset of the power measurement. Clear? So that's the overall situation. I think I have conveyed the message so beautifully. Let's go to the next level and discuss about energy meter. Okay, so this is these are the somewhat questions related to the energy meter. So a single phase energy meter is operating on 230 volt 50 Hz supply with the load current of 20 ampere for 2 hours of time. Please keep this in the mind, 2 hours of time at unity power factor. Wonderful. That is unity power factor. Nice, right? This meter makes 1380 revolutions in that period. Then the meter constant is dash. So I will give at least 5 to 10 seconds time. Every one of you must work on this and let me know what is the final answer from your side. Guys, any answer from your side? Any one of you? Power factor is 0.8. That's okay. This one, this question. Now energy meter basics, let me tell you. So energy meter measures the energy, right? So how do we find the energy? Basically energy is nothing but power into dt. Clear? Power into t. So in fact, if we want to calculate the total energy consumed by the load, we need to know what is the power consumed by the load and multiply that with the time, how much amount of time this is getting consumed. That is the best way to write the energy. Energy is equal to power consumed by the load into time. Now I will give you a simple question. So energy meter will tell you how much amount, in fact, we will have a disk inside the meter, and the disk, even you can go like this also, otherwise. First of all, power is nothing but rate of energy dW by dt here. Clear? So dW, or we can say rate of energy consumption, right? So everything is okay. dE by dt, and dE could be written as equal to PL into dt here, right? So if you integrate both sides, right, so therefore it would be written as 0 to E and this would be written as 0 to T. Clear? So the energy, total energy is equals to power consumed into the time T here. Clear? Very simple calculation. But at the same time, the energy consumption in energy meter will be decided based on the number of revolutions made by the aluminum disc inside the meter. Aluminum disc inside the meter. Therefore, what should I say here is, let me solve this question, then you will understand. Let me solve the first question. There is a meter constant, energy meter constant, energy meter constant, it will be given as equal to energy meter constant. Usually it will be given as number of revolutions that a disk can make when the load consumed is 1 kilowatt per 1 hour session. Clear? Per 1 hour. If 1 kilowatt power is consumed per 1 hour time, then how many revolutions the disk can make? That is called as a meter constant, energy meter constant. Now let me explain here how does it really works. Okay, so please see in this question, what will be the voltage? Rated voltage is 230 volt and rated current is 20 ampere for 2 hours of time, unity power factor. First of all, from previous question, how can I write from previous question? First of all, look at this, 230 volt. What is the total power consumed? Load power would be equal to 230 volt into load current would be how much? 20 ampere. That is also fine. Into basically power is nothing but V into I into cos phi, right? So what is the cos phi? Cos phi is considered as 1 here. So this is 1. So therefore it is simply like 230 into 20. 230 into 20. How much this value is going to be? 230 into 20. 4600. So it is a 4.6 kilowatt here. 4.6 kilowatt. Excellent. So this is the power consumed by the load, 4.6 kilowatt. Excellent. No problem. Now this is being done for 2 hours. The time is how much now? Now the time is almost done for 2 hours of time, correct? So then what he is saying, it is making number of revolutions n. N is being the number of revolutions, and he is saying 1380 revolutions. 1380 revolutions. So 4.6 kilowatt power, if it is consuming for 2 hours of time, how many revolutions it is making? 1380 revolutions it is making. This is the meaning of that. And per time grace, the wattmeter is a linear device. Okay, a wattmeter is a linear instrument, unlike the moving iron instrument or electrodynamo meter. Okay, so that's most powerful thing. You need to keep the basics very solidly in your hand, otherwise you cannot go ahead. So 4.6 kilowatt power, when it is consuming for 2 hours of time, it is able to make 1380 revolution. But I need the meter constant, means number of revolutions per 1 kilowatt into hour. That is what I require. So what I will do here, just see here, let us assume that 1 kilowatt power. So otherwise you can think in this way also. So as everything is a linear relation, there is nothing wrong to say like this. 4.6 kilowatt power, for timing, assume that it is only consuming for 1 hour. Instead of 2 hours, if it is consuming for only 1 hour, obviously the number of revolutions will be half, right? So 2 hours, if it is consuming this much of power, then it is capable to make 1380 revolution. Suppose the same power, if it is consuming for only 1 hour, how many revolutions it will make here now? Fast. 1380 divided by 2, I am sure it is of 690, no doubt about that. 690 revolutions it can make, correct? Very good, very good. Now 4.6 kilowatt, if it is consuming for 1 hour, then it can make 690 revolution. Then my question straight away to you is, 1 kilowatt, if it is making for 1 hour time, how many revolutions it will make now, right? 4.6 kilowatt, it can make 690. 1 kilowatt, how much it can make? Because the time we are fixing now as 1 hour. So therefore, it is a linear relation once again. 690 divided by 4.6. 150 revolutions, right? 150 revolutions. Such a wonderful question this is, right? Most of the students, they struggle to do multiple calculations here, and they will remember the formula, that this finally they will end up with the wrong answer, and they will come to my class next year also, right? Now this shows clearly that if 1 kilowatt power is consumed per 1 hour continuously, the disk is able to make 150 revolution. It should make 150 revolution. Therefore, what is meter constant now? Now finally I can say meter constant equal to 150 revolutions it is able to make, or it will make, when it is consuming a power of 1 kilowatt hour. Clear? That's the good question. Have you enjoyed this question, Raghuram and Kumari, other guys, whoever are there in the chat box, Anandi Bose and Lokesh Patu, all of you. Such a beautiful question, right? Simple. But majority times I found this kind of questions in not only in the GATE examination, even in the other PSU examination also. Clear? Now I'll show you one more question. This you will really enjoy a lot. Please see, a 230 volt 10 ampere single phase energy meter makes 90 revolutions in 3 minutes. Very good. So this is what is the information. 90 revolutions per 3 minutes, right? At half load. Wow. At half load. Rated voltage and current F at half load and rated voltage and unity power factor. Good. Once again, right? So if the meter constant is 18,100 revolutions per kilowatt, right? Then the error, or then its error at half load will be dash. Right? Its error at half load will be dash. Hey, this is Raghu, how much lengthy calculation? This is a simple calculation. It is like an aptitude question. Even I have done a lot of steps, but you don't really require this much steps if you are clear with the calculation. Okay, right. Now let's go to the next one. First of all, what is the load power? Look at the load power. Load power is, or else first let me see, meter constant. Meter constant is what? Meter constant is all the way related to the meter, that is 18,000 revolution, 1800 revolutions per kilowatt hour. That means according to meter constant, which is given by the manufacturer, what should I say is, if 1 kilowatt power is observed, 1 kilowatt power, if it is consumed for 1 hour time, then it is really capable of making how much? 1800 revolutions. This is the meaning of this. 1800 revolutions. Fine, super. Alright, but at this point of time, what is the load power that is consumed? The load power consumed is load power, PL I am writing. So PL is equal to rated voltage. Rated voltage is how much? 230 volt. 230 into rated current is 10 ampere, but we are operating at half load. Look at that, half load we are operating. Half load we are operating is 10 by 2, that is 5 into cos 5 is 1. So how much this is? 230 into 5. Anyone, can you help me? Nice question. Yes, thank you Praveen. So 230 into 5. So that will be equal to 1150. 1150 or what? Or we can say 1.15 kilowatt. Clear? This is the power that is currently being consumed by the load. This is the power currently being consumed by the load, right? So now it was also said like it is consumed only for 3 minutes of time. Only for 3 minutes of time. That's also given. 90 revolutions are made in 3 minutes of time. So that means he is saying that 1.15 kilowatt power is consumed for 3 minutes of time, and in these 3 minutes it is making 90 revolutions. 90 revolutions. Now he is asking the question whether the disk is fast or slow. How do we decide that? So this is what happening right now in my home or in your home, wherever you are using this energy meter, as it is consuming a power of 1.15 kilowatt in 3 minutes of time, it is making 90 revolution in practical situation. In practical situation when you are using. But ideally what should happen? Ideally look at that, what should happen? So this is a practical environment, right? But ideally look at that. So let me write down once again here. According to meter constant, ideally speaking, if it is consuming 1 kilowatt power for 1 hour of time, then it should actually make 1800 revolution. Correct? 1800 revolution. Now just look at that. This is the ideal situation according to the manufacturer's specification. Instead of 1 hour time, let me do in minute calculation. This is 60 minutes. Okay, 60 minutes. Now let us say like this. Same 1 kilowatt power, if it is consumed by 3 minutes, then what should I say? So instead of 16 minutes, 60 minutes पे 1800 हो जाएगा, but like 3 minutes पे कितना हो जाता है? So 3 minutes means 20 times it should be divided. So 1800 divided by 20. So how much that will be? Can anybody say? 1800 by 20. So 90, right? So this is going to be 90 revolutions here. This is absolutely okay. Same 1 kilowatt power, if it can handle only for 3 minutes, then it should actually make 90 revolutions. That is perfectly all right, right? But let me ask you a question. Suppose instead of 1 kilowatt, if it is a 1.15 kilowatt, then 1.15 kilowatt, 3 minutes of time, how many revolutions it should make? So 3 minutes of time, 1.15 kilowatt, 3 minutes of time. Then how do we write the same logic here? 1.15 into 90, ideally it should make 103.5 revolutions. Either 105 or 104 or 103 it should make. Correct? So that means one can easily understand that yes, after this much of hard work, ideally according to the meter constant, if the power consumption is 1.15 kilowatt for 3 minutes of time, the disk should make 103.5 revolutions. Correct? But in practical case, what happened? Practical case, when it is consuming 1.15 kilowatt in 3 minutes of time, it is making 90 revolutions, right? So 90 revolutions. Therefore, what would be the error now, right? What would be the error? Simple. This is the true value. This is what should happen. But this is the measured value. Anyway, we are in the linear calculation. So the percentage remains same. Percentage of error equal to measured value minus true value by true value into 100. So fast. Use your calculator fatafat and tell me what is the final answer. True value is, measured value is 90. Revolution minus 103.5 here divided by 103.5 all the way into 100. Any one of you, can you help me here? What is the answer? Answer is what? So 90 minus 103.5 divided by 103.5. I'm very sure it will be like into 100, minus 13.04, minus 13.04%, minus 13.04%, right? Very good, Kumari, very good. Error is minus 13.04. But now you tell me whether it is running slow or running fast according to our expectation. Whether it is running slow or running fast. Running slow or running fast. Any idea from your side? Running slow or running fast? So ideally it should make 103.5 revolution when it is consuming 1.15 kilowatt power for 3 minutes. Practically it is making 90 revolutions when 1.15 kilowatt is consumed in 3 minutes of time. That means it is running slow, That means I can say the error is going to be 13.04 and running slow. So option A is the correct answer for this question. Once again, this is a good question. Correct? Once again. See, when you say slow, almost, if you don't mention slow, then you have to write like minus 13.04. If you mention slow, then 13.04 is the correct answer. So is it a good question or not? How many of you really enjoyed this question? I want to know from your side. I want to see your response. That will really give a lot of energy to me. So please let me know how many of you really enjoyed that question. Very good, right? Nice question. Thank you. Now let's quickly go to the next concept, that is measurement of RLC. That is basics of AC bridges. Okay, basics of AC bridges. So AC bridges, there are wide number of AC bridges. Trust me, a lot of bridges are there. Right? If you ask me to discuss all the bridges, it takes naturally a lot of time. But every bridge will follow only one fundamental. Right? So what we do is, let's try to learn that fundamental, or let's try to learn that basic point, and we will amplify the basic to any question. That is the best way of learning. It is not required to remember each and every formula. It is required to remember the fundamental point which can be accessed to thousands of formulas. Clear? That I will give especially in AC bridges. First of all, in AC bridge, the purpose of AC bridge is to measure RLC, right? Inductance, resistance and capacitance. And you know, Wheatstone bridge, DC bridge is used specifically for resistance measurement. So as I am dealing with the AC bridge, let me take first AC source like this. This is the AC source, right? AC voltage source. For time being, let us say VI of t. It may have some kind of, you know, peak voltage or RMS voltage at some frequency. That is all fine. Now let me take that 4 impedances are there. Okay, so Z1, let me say this is Z1, and let me take here Z2 for time being, right? And here let us deal with the third one, that is Z3 here, and of course here we do have Z4 here. Clear? This is Z4 here, and of course in between we will be having a deflection meter. So this is a meter, right? So deflective meter. Fantastic question. Thank you very much, Praveen. So this is the deflection meter. This is meter. So at balanced condition, what happens is, especially when we are dealing with the AC bridge, at balanced condition, fundamentally the cross product of this, if the bridge is in the same configuration, the product of opposite impedances must be like this. Clear? So therefore I should write down clearly that at balanced condition, Z1 into Z4, that must be equal to Z2 into Z3. Clear? Z2 into Z3. This is perfectly the primary condition to be satisfied. But Z is an impedance. If it is an impedance, then we will going to have magnitude condition here. Magnitude condition means, look at that, magnitude condition means the product of, that is magnitudes, product of magnitudes means magnitude of Z1 into Z2, magnitude of Z2, so Z4, that is equal to magnitude of Z2 into magnitude of Z3. This is considered as a magnitude function. However, the phase function or phase condition, how do we write the phase condition? Phase condition could be written as phase of Z1 here plus phase of Z4 here, that must be equal to phase of Z2 plus phase of Z3 here. That's how exactly we do the things. I hope you understood clearly, right? So most of the times in the bridges, we can directly use this one. However, if the magnitudes and phases are given, then we can use this. But this is the fundamental point what I should say. You have to keep this in your mind every time when you are dealing with the AC bridges. What I do is, first I will use this basic and solve some questions, and later I will show it to you how you can amplify this to any other bridge here. Clear? So that's the best way to learn. Now let me come with the first one here. Yeah. So let's see this question and try to solve this question. Every one of you be on your toes and solve this question. But before that, let me tell you one simple thing. See, as I said, for inductance measurement, or else let me tell you in this way, especially in AC bridges, it starts with first one, Maxwell's inductance bridge. Okay, Maxwell's inductance bridge. Second is Maxwell inductance and capacitance bridge, or simply people do say that this is a Maxwell's capacitance bridge. And third one is going to be Hayes bridge, which is very important. I am writing only important things, but in general there are many bridges are there. Bridge concepts are unlimited. N number of bridges are there, but I am going with the basic things, and in fact which we use so regularly. Okay, next one is Woven's bridge. Okay, Woven's bridge, and all these four are specifically used for inductance. Okay, these four are mainly used for inductance measurement, inductance of a coil. Clear? And Hayes bridge used for high quality factor, high Q coil, and Maxwell is used for low Q coil. Clear? So because in Hayes bridge the calculations will be of frequency dependent, so we go with the high quality factor coil. And apart from these, we do have some other bridges also, that let me write down. One is the Lissajous bridge and modified Lissajous bridge. Lissajous bridge. And second one is Screen bridge. And these two, Screen bridge, are ING, right? So these two are for capacitance measurement. Clear? These two are used for capacitance measurement. And see, it is very easy to remember. In case of Hayes bridge, H and H, you can keep like this in your mind. Hayes and high. That is easy way to remember. Now after all these things, there are two more specific bridges which are quite important as far as the GATE exam is considered. One among that is a Wien's bridge. Clear? So please try to keep in your mind Wien's bridge. And Wien's bridge is for oscillator. This is basically for oscillation generation, or it is for frequency measurement. By using this, we can measure the frequency of the source. Clear? So we can measure the frequency of the source. That is also very important measurement only. Frequency measurement. Clear? Frequency measurement. And most important is Kelvin double bridge. Any one of you, can you tell me Kelvin double bridge is used for what? Kelvin double bridge is used for the low value of resistance, low value of R. I am writing like R, which is nothing but resistance. Clear? So that's the overall idea of the all important bridges which are so frequently asked in the GATE examination. But if anybody want to go deeply into Maxwell bridge and want to know how the things are placed, how to calculate and all these things, I sincerely suggest go to the notes, okay, or go to the recorded lectures, because it is a marathon session. So I need to revise this and go for the questions. However, if you know how to solve the question, that is more than sufficient. Either you will be getting a theoretical question like this. If you get a theoretical question, this slide is more than sufficient. And if you get a question like this in the exam, you can solve that question from the basics. So you don't really require to remember any formula. technically speaking, no need to remember any formula in the complete AC bridge concept. You have to remember basic. Just take 2 minutes of calculation, you will get the answer. If you try to remember something, you will do mistake in the final examination. That is what my practical, my experience says. So let me show you how to solve the questions in the GATE exam directly from the basics without remembering any formula. So see, the bridge shown in the figure is balanced when R1 is equal to 100 ohm, R2 is equal to 210 and C2 is equal to 2.9. Okay, good. And R4 is equal to 50 ohm. Then 2 kHz sine wave generator supplies the voltage of 10 volt peak to peak. The value of L3 in millihenry is dash. Clear? So you require to find the value of L3. So first of all, try to understand that this is Z1. Clear? And the parallel combination of these two is considered as Z2. So the parallel combination of these two is considered as Z2. And this is Z4 straight away. And the series combination of these two will be considered as a Z3 here. Clear? Z3. And this is detector as usual. This is detector. Relax. Try to find out what is Z1 and Z2 and Z3 and Z4 first. So first of all, Z2. How much? Z1 is R1 already I told you. Z2 is what? Parallel combination of capacitor and resistor. How do we write that one? R2 into the impedance of capacitor 1 by S2 divided by R2 plus 1 by S into C2. So this will be equal to how much? R divided by 1 plus S into R2 into C2. If I am not wrong, this is correct, right? And then moving ahead, what would be the value of Z3 here? Relax guys. Z3 is R3 plus SL3. SL3, and this would be written as R3 plus J into omega into L3 here. J into omega into L3. This could be written as here R2 divided by 1 plus J omega into R2 into C2. That's I hope you got the lines here, right? Now, according to balanced condition, what should I say? These two, product of these two must be equal to product of these two. Therefore, what should I say? Z1 into Z4 equal to Z2 into Z3. Clear? Right. Now, moving ahead, Z1 into Z4. What is that? Z1 into Z4. Z1 into Z4, already I told you, Z1 is R1, Z4 is R4. So just look at the diagram here. Z1 into Z4, I think you got it one. When it is balanced condition, you should multiply with the Z2 and Z3 also. So therefore, Z2 and Z3. Z2 is how much? Z2 is R2 divided by 1 plus, how much that is? 1 plus J omega R2 C2. R2 C2 and R3 plus J omega into, what is that? L3. See, it takes time. I agree with this. Okay, but you must do more practice rather than by heart in the formula. Because when you are in the exam, you need not write all the steps, because this step is not required. Directly you can write the first step as like this in your rough book, right? In your rough paper, directly you can write down this step. Why do you require to solve everything? It's not a conventional question, right? Directly you can write this as a first step and then cross multiply here. I'm very sure it will come like R1 into R4 into 1 plus J omega into R2 into C2. That must be equal to R2 into R3 plus J omega into L3 here. J omega into L3. Then you will be getting like R1 R4 plus J into omega R1 R4. Okay, R2 C2. This is equal to R2 into R3 specifically plus J omega into R2 into L3. Clear? R2 into L3. Fine. That's exactly what I mean to say. I think we got that one, right? So now compare both sides, real part and real part, both sides. Then R1 R4, it must be equal to R2 R3, and we require R3, which is nothing but the resistance of the inductor, which is equal to what? R1 R4 divided by R2. Excellent, outstanding, right? R1 R4 divided by R2. And from this, what about if you compare the imaginary part? Imaginary part, if you compare this part and specifically this part, both will be same here, right? Therefore, I could say R1 R4 into R2 into C2, that is equal to R2 into L3. Omega is not required here, correct? R2 into L3. R2 into L3. Now relax. What is L3 from here? L3 equal to R1 R4 into C2. Clear? R1 R4 into C2. This is exactly L3 and this is exactly R3. Therefore, we got like resistors and inductor. Correct? Now, what is the question? Go back to the question once again. The question is calculate the value of L3 in millihenry. You are required to calculate only L3. How do we get L3 now? Now L3, after this much of hard work, directly we can put it. So L3 equal to R1 into R4. What is R1 here? R1 into R4. 100 ohm and 50 ohm. One second. 100 ohm and 50 ohm. 100 into 50. 100 ohm into 50 ohm into C2. What is C2? C2 is 2.9 microhenry. So 2.9 microfarad. 2.9 into 10 power minus 6. Fatapat, all of you do this and tell me what is the final answer here. Guys, fast. 100 into 50, 5000 into 2.9, 14,500, right? 14,500. So 1.45, 14,500, 14.5 millihenry. Clear? 14.5 millihenry. That is going to be your final answer. Yes, yes. Because the options are in millihenry. You require to get the value in millihenry. See guys, this is also important. Sometimes in the bracket they will keep millihenry and you will get the answer as 0.0145 and you will directly keep 0.0145. No, be careful. When it is millihenry, then your final answer must be 14.5. 14.5 is the correct answer for this question. That's how exactly we do. Now I'll show you one simple magic here. So all of you please see one simple magic. Can you tell me, because you got to know what is the value of inductance. What is the value of resistance here? R3. Can you tell me what is the value of R3 here? You can calculate this and let me know what is the value of R3. But the quality factor of a coil. So we can easily measure the quality factor of a coil also. Quality factor of a coil. How do we measure the quality factor of a coil? Q is equal to omega into L3 divided by R3. Simple. This is the quality factor of a series RL circuit. Correct? Series RL circuit. And now in your bridge, series RL is there. So quality factor can be written as omega L3 by R3. No doubt and no confusion here. So omega into, relax. What is L3 and what is R3? Fast. L3 and R3. L3 equal to, yes, R1 R4 into C2. R1 R4 into C2 divided by R1 R4 C2 divided by R1 R4 divided by R2. So therefore, easily we can say and rewrite this as R1 R4 will be out here. R1 R4 will be out. Therefore, quality factor could be written as omega L3 by R3, or we can also say omega R2 C2. Both of these two are correct only. Clear? Both of these two are correct. Because if you look at clearly, L3 and R3 are series RL circuit. R2 and C2 are parallel RC circuit. For parallel RC circuit, this is the quality factor. Fine. So quality factor of the inductor can be measured in terms of the quality factor of a known capacitance. The idea is so simple. Here Z2 is known and we will vary the value of capacitor and resistor, or at least one out of these two or both of these two. Means this is known to you and this is unknown. This is unknown. Correct. That's what even in the question also they mention the value of capacitance and resistance. This set is given to you, this is given to you, this is given to you. This is unknown to you. That means the unknown quality factor of a coil can be calculated from the known values of the resistance and capacitance. Clear? That's the beauty of the overall Maxwell bridge. Whatever I have discussed here, now this is called as a Maxwell inductance and capacitance bridge or Maxwell capacitance bridge. That is the second one. That is the second one. Now you tell me, without knowing the name of this, are we able to solve this question? Yes or no? Tell me first in the comment section. Without knowing the name of the bridge, we are able to solve this from the basics. Am I right or not? Please let me know in the comment section. I have not used any of the formula. I have used only basics to solve this. Then you may ask a question, sir, in the exam, how we can do all this calculation? One thing is, in the exam, you will not do all the steps clearly like the way how you are writing in the university exam or the conventional paper. What do you do in the exam? In the exam, simply you will write this as the first step. And from here to here, it takes maximum of 1 minute only. If you want, you can try to check it that. Right? Then you may argue with me, sir, why do I really waste that 1 minute? There are some intelligent people, they question me, sir, why do I really waste 1 minute? Okay, fine. If you don't want to waste that 1 minute, you will do the mistake here. In the calculation of L3, instead of writing R1, R4, C2, you will write like R2, R4, C2. Finished, over. And again, you will come to my session for next year. Okay. So you have to always go for the trade-off, right? So where to go with the formula, where to go with the basics, right? When multiple things are there on the same formula, it's better to go with the basic. Okay. Now let's go with the second question on this RLC measurement. The parallel resistance capacitance bridge shown below has a standard capacitance of C1 is equal to 0.1 microfarad and a resistance value of R3 is equal to 10 kilo ohm. The bridge is balanced at a supply frequency of 100 Hz with the R1 is equal to 375. Okay. And R3 is equal to 10 kilo ohm. R4 is equal to 14.7 kilo ohm. The value of the dissipation factor D, which is equal to 1 by omega RPCP. See, you must understand, dissipation factor is the inverse of quality factor. Dissipation factor is the inverse of quality factor. So when you have parallel combination of resistance and capacitance, what was the quality factor we have seen? Omega into R2C2. But dissipation factor will become reverse. Okay. Of the parallel combination of CP and RP is dash. Well, so we require to know what is the dissipation factor of this unknown branch. This is unknown branch. Correct? First of all, look at this. Tell me, can I write like this? Z1. Z1 is nothing but R1 divided by 1 plus j omega R1 C1. Simple. Because this is the parallel combination of these two. Already we have solved this. And similarly, what about Z2 now? Let us do Z2. Z2 is equal to, let me take this as an unknown impedance, Z2. Okay, Z2. Z2 will going to become like RP divided by 1 plus j omega into RP into CP. Correct? RP into CP. Relax. Those who understood up to here, go for the basic condition. Again, this is Z3 and this is Z4 here. Z3 and Z4. Right? So in exam, we'll always get the standard C. Yes, yes, yes. Correct. Correct, guys. So Z1 into, now product of these two. These two must be product of these two. So Z1 into Z4. Z1 into Z4. This must be equal to Z2 into Z3. No doubt about this one. This is different. Z1 into this one. So this is R1 divided by 1 plus j omega into R1 C1. Z4 is R4. R1 R4. Let me write down directly. It is equal to Z2 is RP. Z3 is R3. R3 divided by 1 plus j omega into RP CP. This is symmetry. Okay. So, but anyway, let me go one step ahead. So, from this equation, if you go one more step, what you will going to get? R1 R4. No doubt about that. R1 R4 into 1 plus j omega into RP CP. This is equal to what you will get? RP R3. RP into R3 whole into 1 plus j omega R1 C1. 1 plus j omega R1 C1. Clear? So you may argue with me, sir, if you remember the formula, maybe we don't require to do all these things. Remember, sometimes in the exam, you will be asked a bridge question which will not match with any of the standard bridges. That means there is a possibility to get a bridge question which is not there in all these bridges. They may give some other new bridge. In that case, what you will do? You have to follow these basics only, right? So that's why basics are always powerful. So go ahead still. R1 R4 we can write down like this. R1 R4 plus j omega into R1 R4 into RP into CP here. Right hand side you will be still having like RP R3 plus j into omega into RP R3 into R1 and C1. Now relax. When you compare the real parts on both sides, R1 R4 is equal to RP R3 here. Therefore, if you go ahead again, RP is equal to R1 R4 divided by R3. Number 1, this is easy. And then what is the other side here? J omega R1 C1. Yes, j omega R1 will get cancelled. So if you compare the imaginary parts here, correct? So it will become like R4 into RP into CP, that is equal to RP, R3 into C1. R1 get cancelled on both sides. RP also gets cancelled on both sides. Then we require CP. CP is equal to R3 into C1 divided by R4. So please try to see, these are the two values what we required here. I hope you understood this. Correct? These are the two values what we require and we got that one. But dissipation factor is what? The question of dissipation factor is here. Dissipation factor. How do we write the dissipation factor here now? The dissipation factor could be written as 1 divided by omega into RP into CP. Relax. Just go ahead with your data. 1 divided by omega into RP is how much? RP is R1 R4 by R3. R1 R4 divided by R3 here. Correct? Into CP could be written as R3 into C1 divided by R4. Correct? Now the most beautiful point will end up here. So please see. R4 will be out, R3 will be out. So the dissipation factor could be written as 1 divided by omega into R1 and C1. When you do multiple questions or when we practice multiple questions, then you will directly able to write, yes, for balancing, this will balance in terms of this one. Sorry, this will balance in terms of this one. Then both are parallel combination. So when both are parallel combination, quality factor of this will be in the same lines with the quality factor of this, and dissipation factor of this will be in the same lines of the dissipation factor with this. Clear? So likewise, whether you write D is equal to 1 by omega into RP into CP, and whether you write like 1 by omega into R1 and C1, both are same. That is the meaning of this statement. Clear? Now we have R1 value, C1 value and omega also. What is the omega value here? Can you see omega and tell me for me? So this is 100 Hz. Omega is equal to 2 pi f. Again here also you will do the mistake. Instead of converting that into radian per second, directly you will take omega is equal to 100. That is also some of the mistakes. I mean, these are the possible mistakes students commit in the examination. So omega, and this is radian per second. Now take this value of omega and substitute here, and R1 and C1 are known to you, then calculate the value of dissipation factor. Clear? This is, I would rate this question really as a good question, but not so difficult question, technically speaking. So guys, we have two more topics left, right? It may take another half an hour. Shall I take continuation and complete this? Please let me know in the comment section. I need your suggestion, everyone's input here. Everyone input. So shall I continue this and complete this? Just it will take another 15 to half an hour time. So cathode ray oscilloscope. This is, yes, okay, cathode ray oscilloscope is an instrument which is used to measure the amplitude, frequency, phase. Suppose if I have a signal like voltage, Vt is equal to Vm into sine omega into t plus phi, right? I want to know what is the phase, okay? I want to know what is the phase, what is the frequency, what is the, Vm, peak voltage. To measure all these three, we can use CRO. CRO is a display element, right? So cathode ray oscilloscope is a display element. Now first of all, let me show you a simple question here. See, a voltage of 6 volt cos pi t, cos 1000 pi t. So CRO, first of all, let me say, it's a device used to measure the amplitude of the waveform, amplitude, phase, frequency, and time period. Naturally, if you measure the frequency, then time period is a bonus to you, right? So 6 cos 100 pi t V is fed to Y input of a CRO. That means it is a test signal. Test signal means we need to display this one. Test signal means we need to display this one. Good. And on the CRO, the X and Y settings are dash. Okay. So when you display this on the screen, what happens is the waveform will be displayed, right? So look at that. On the Y axis, vertical side, how many boxes here? 1, 2, 3. So 3 boxes or 3 divisions must show how much voltage of peak? 6 volt. So 1 division will be of how much? Setting. 1 division will be of 2 volt. So that means it must be 2 volt here, 4 volt here, and 6 volt here. Sorry, I made wrong here. Just give me 1 second time. Yes. It is 2 volt here, 4 volt here, and then 6 volt here. So the setting on x-axis is 2 volt per division. So this is x-axis setting is 2 volt per division. Correct? Yes, very good. Now y-axis division is what? This is y-axis. I'm sorry. Extremely sorry, guys. This is y-axis division. Now look at x-axis division. How do we find x-axis division here? 1 and 2. First box, second box, third box, 4, 5, 6, 7, 8, 9, 10. So that means on y-axis, on x-axis or horizontal axis, 10 divisions are representing the time period of this one. 10 divisions are representing the time period. What is the time period of this waveform? So look at that here. Omega is given like 100 omega t, 100 pi, and omega is equal to 2 pi f here. 2 pi f is equal to 100 pi. Therefore, f could be written as 50 hertz here. F is equal to 50 hertz means what is the time period? Time period is 1 by f, which is equal to how much? 1 by 50, right? 1 by 50, that is 20 millisecond. Am I right? Yes. 1 by f, that is equal to 20 millisecond here. 20 millisecond, outstanding, 20 millisecond. So 10 divisions are representing one complete wave here. 10 divisions are representing one complete wave. So 10 divisions are representing 20 millisecond here. Therefore, one division, what should it will become? One division will become 2 millisecond, right? So therefore, the x-axis setting is what? Finally, x-axis setting could be written as 2 millisecond per division. So what would be the correct answer here? The correct answer would be equal to option D, right? Am I right? 2 volt per division, 2 millisecond per division. It's a simple question, I should say. That is how we measure the amplitude and frequency and time period. Because once you know the time period, then calculating the frequency is a cakewalk to you, right? Both are known to you, right? Now going to the Lissajous pattern, which is also one of the very, very important thing. See, in CRO construction, we will be having horizontal plates, horizontal deflection plates, vertical deflection plates, horizontal plates and vertical deflection plates in CRO. If you are giving sinusoidal signal to horizontal deflection plate, let us say V1 into, let me say otherwise, we are giving x-axis. Horizontal deflection plates are subjected to sinusoidal signal. So sine omega s, or else we can even take this as like this. Two pi fx into t plus phi, right? And phi x, phase of the x signal. And Vy of t, do one thing, let us not take the phase of this signal, that would be better. Then only you will get an easy way to understand. So Vy of t equal to Vy into sine 2 pi Fy into t plus phase. Clear? Plus phase. Right? That means the actual phase difference between both the signals is phi. Phase difference between both the signals is phi. Right? Now I want to know what is the phase difference between both the signals. When I apply the sinusoidal voltage to horizontal deflection plates as well as vertical deflection plates, then you will be getting the pattern. There are some patterns that are naturally comes on the CRO panel. Suppose let us say on the CRO it is displayed like this. Okay, it is displayed like this. Please see here. Okay, so it is displayed in this way like this. There are a lot of combinations, I do agree with that, right? But with this you can go minimum at least. Okay, right? So first thing, let's see where it is cutting this one. So this would be said very clearly as the first one x1, and the peak value would be said here x2 here. Clear? X2 here. So x2 here, the peak value is considered as x2. Then the phase could be written as equal to sine inverse of x 1 divided by x2, because inside the bracket smaller value should come first and later larger value. x1 by x2 will be the answer, right? So x1 by x2. So x1 is the value where it is cutting here, and x2 is the peak value that we can see here. Clear? Similarly, we can even do, because it's a symmetrical graph, here also we can do like this. y1 we can cut it here, and the peak value you can calculate here. So maybe the peak value here we can see that as, you know, y2 here, and then the phase can be written as, or we can say phase is equal to sine inverse of y1 by y2. These are some important calculations which you must keep in the mind. And there is one more important thing, that is, see, phase can be calculated like this, and the net voltage on the CRO, if you take at any point, net voltage, if you see, the net voltage is actually nothing but net voltage on the display. Net voltage on the display must be always equal to under root of Vx square plus Vy square. Clear? So Vx is the amplitude of x of t, Vx of t, and Vy is the amplitude of Vy of t. Clear? Now, how do we calculate the frequency? So, just let me tell you one simple graph here, frequency ratio. Suppose let us say there is a graph like this, or the Lissajous pattern is coming all the way like this. Clear? It's coming like this. One second, otherwise. This is the Lissajous pattern you are having, and you need to know what is the frequency ratio. Suppose frequency of the Y signal divided by frequency of X signal is equal to number of horizontal tangencies or intersection point, horizontal tangencies I could say. What does this mean? I will tell you, just give me 1 second. Divided by number of vertical tangencies. Clear? That's all. It's easy. Now look at that. What is horizontal tangencies versus vertical tangencies? Fy by fx. This could be given as, look at that, horizontal tangencies. If you want horizontal tangencies, simple. Draw a line horizontal to the curve such that it can intersect maximum number of time. It can intersect maximum number of time. Look at that, how many times it is intersecting the pattern now, Lissajous pattern. Any idea? See, this is the first time it is intersecting, second time, third time, and fourth time. Horizontal line is intersecting 4 times, means number of horizontal tangencies are 4. And now, if you want to know vertical tangencies, simple again, draw a vertical line which intersect maximum number of times. Don't draw the line here, okay? Because if you draw the line here, it will not intersect maximum number of times. That way, we should draw the line exactly here, vertical line, so that it will intersect maximum number of times. See how many times it is intersecting the figure here, or the Lissajous pattern. So it is intersecting here 1, and it is also intersecting the Lissajous pattern. See, the blue color one is as the Lissajous pattern. Lissajous pattern, right? So 1 here and 1 here, 2 times. So therefore it will be 2. Finally, I can say Fy is equal to 2 times of Fx. So that means if I know the value of Fy, suppose if in the question, it will be given in the question. No need to worry about that. In the question, it's mentioned as 1 kHz. Right? If Fx is equal to 1 kHz, then you can say Fy is equal to 2 kHz. Clear? This is how exactly we can measure the frequency. I hope you understood. The most important point and the brilliant point is, when you write Fy by Fx, the ratio must be taken in the opposite way. Clear? So please see here. Ratio must be taken opposite way. That means y by x should be written like horizontal by vertical. Most of the students, they reverse this and take the wrong answer. Go for wrong calculation. They will take, like students used to take sometime by mistake, like number of vertical by horizontal. No. When you write y by x, here reverse must be there, horizontal by vertical. Hope I have conveyed the message so clearly to you. And here I have explained how to get the phase calculation. Here I have explained how to get the frequency. And here I have explained how we can get amplitude. So all things I have completed, worked out very well. Now it's the time to go for the DVMs, digital voltmeters. which is considered as the last concept here. So please see all of you. So there are many concepts are there in DVMs. I should say that n number of concepts, because measurement is an unlimited topic. Do you know why it is considered as an unlimited topic? Every day some new, in this great technological revolution, evolution is the bonus for us, right? Every day you will get new measurement. So but it is not possible for someone to explain all different types of instrument. We need to go only with respect to GATE syllabus, right? So let me show you one important thing. Display. Digital meters, the most common things in the digital meters is their displays and advantage. So obviously the advantage is the resolution. Display is also accurate measurement, right? So 3 end of display or 3 end of digital voltmeter means what? 3 end of digital voltmeter means the display looks like this. People do call this as a half digit, and this is also half digit only, and this is also half digits, right? So all together, and this is called as a full digit. So in the display, full digit ka matlab kya hai? So half digit means, first of all, it can go from 0 to 9, okay, 0 to 9, and it will also go from 0 to 9, and it also goes from 0 to 9. But half digit means it can go from 0 to 1. So whatever you are seeing here, this is the maximum possible bit on the, it's a maximum possible bit on full bit. So please remember this point. Whatever you are seeing on the numerator, that is the maximum possible display on the full digit. Altogether 2 bits can be represented. Now can you tell me, if this is the case, what would be the minimum value? So the minimum value is full bit can show 0, half bits can 0 0 0 0, right? So this is the minimum combination. And what would be the maximum combination here? So maximum combination is this, all 3 can show 999 here. And look at the most beautiful point, this can turn out to be 1 here, correct? 1999 could be the maximum possible value. That is what exactly it was written, right? And most important thing is, at this point of time, don't worry about, the full scale value. Don't worry about the full scale value. Just look at this thing, full digit and half digit. I think you understood this clearly, right? Half digit means it can carry or it can display from 0 to 9 any number. Full digit means it can display only some numbers. How to decide which numbers it will decide? It starts from 0, whatever is there in the numerator here, that it will going to display maximum. So 0 is possible, 1 is possible, max, that's all. Now, can you tell me from 0000 to 19999, how many counts are there? First minimum value is 0000, and then next, this is considered as a first count. Second is going to be 0001. Next is going to be 0002, right? Next is likewise, if we continue like this, how many, what is the last one we got? 1999. Can you tell me how many counts are there from here to here? How many counts are there? Number of counts. You started from 0 going for 1999, including 0 till 1999. How many counts will be there? Number of counts is equal to 2000. Number of counts is equal to 2000. I hope you understood this one. And most importantly, the resolution of any particular DVM, especially these DVMs, is equal to 1 divided by 10 to the power of n. Let me go 1 as a full scale value, okay? 10 power n. And where 1 is, n is nothing but number of full bits. Please keep in your mind, number of full bits here, or full digits. Number of full digits here. 1 second. Number of full digits. Clear? So there is an important point I would like to explain. Let me show you here. Suppose the range selection. Which range? Because when we keep 1 volt, I told you what will happen. Suppose if the range selection is like this. Look at that. You want to measure from 0 to 1. Okay? 0 to 1. Now, the decimal will come like this, and the minimum value it will show is 0.00002. Maximum value is 1.999. So this 9 will not be there. I am sorry. 3 end of digit means it will be stopping at this point. That means if you look at the full bit may go from 0 to 1, half digits are taking from 00 to 000 to 999, right? Then over range, that is not required. So look at this setting. So 0, 000, 0, 0.00002 to 1.999 it can go. I hope you understood, right? Similarly, 0 to 10 if you are measuring, then 0 to 10, yes, 0 to 10 if you are going means maximum, this is a full range. This is the full range, that is 0.002, 19.99 it can go. But actually our value is how much? 10 volt only, right? Then it will show like 0, 9, 1 second, let me take another color. Then it will show like 0, 9.99. So this is technically 9.99 volt. This is technically 9.99 volt, where your 10 volt is the maximum value you can measure. And 0 to 100 if you are doing, then 0.000 to 199.99. This can go up to here because the resolution is 1 by 10. Resolution is going to be how much? Here I told you that here 1 by 10 power n, because I took the scale as 1. If you take scale as 100 by 10 power n we need to do, right? 100 by 10 power 1 we need to do. So simple. So this is going to be 1000. See, 100 by, when we are using the full scale as 100 by 3.5 means 3 bits. So it will be 0.1. Clear? So then it will be showing like 0.001 and 0.2, like that it goes, right? That's what exactly it was mentioned. So that means it is 0.000.0. It starts because it is 0.1 means this is how it starts. So every time resolution means you need to keep the full scale range divided by 10 power n. Clear? Suppose instead of 10, if I have, instead of 100, if I have something like full scale range as 10 divided by 10 power 3, how can I write this one? This is 0.01, right? So in that case, so minimum value is 0.01, 0.02. Likewise it goes, and full value what you want to measure is, yes, that is what you can see here. When you have 10 volt, this is how exactly the display is. Started from 0.00. So this is the minimum value is 0.00. Next is going to be 0.01. Next is 0.02. Likewise it continues when your full scale value is a 10. When your full scale value is going to be 10. Clear? Suppose if the full scale value is 1000, what does it mean? Now calculate resolution fast. Resolution is equal to full scale value is 1000 divided by 10 cube. 10 cube is also 1000. So it will become obviously 1, right? 1. So if it is 1 means every reading will be 00001. So it starts with all the way 0000. Next is 0001. Next is going to be 00002. Last is going to be 1999. Likewise it continues. Actually there is a mistake here, right? So look at only the first 3 one. I think I have conveyed the message clearly to you, the way how we can use the resolution in the decimal location also, how to keep the decimal and all these things. So when we can measure 0 to 100, our capability is 199.9. This 9 is not required. Clear? It is not required. It is not required here, and here also it is not required. There is a mistake, so please rectify that. Clear? So I hope you understood this column. So it starts from 0000.0. Next is 000.1, 000.2. Likewise it will go for 199.9. Right? Thank you, Raghuram. Thank you very much. Right? So with that I have completed the most important points, the way how the display is on the DVMs, the way how we can see what is the meaning of full digit, half digit, all these things, all these concepts are completed. Now let's come to the last concept or the last question of the day, that is, okay, right, 1 second. Oh, 1 second guys, just give me 1 second time. One second. Yes. Right. So as I said, there are so many DVMs are there, but out of all the DVMs, the dual slope DVM is a very, very important point. Dual slope DVM, basically the digital voltmeters, what they do is they will have analog to digital converter and then voltmeter setup. So ADC plus voltmeter setup together, it will be called as a DVM, digital voltmeter. Means digital voltmeter converts the analog voltage into digital value and then measure the digital value. Finally, our output will be digital. Clear? That's the magic and beauty of the digital meters. Anyway, a 200 millivolts full scale dual slope analog to digital converter has a reference voltage of 100 millivolt. Good. So let me write down first of all. V reference is equal to 100 millivolt. If anybody completes the question, you can all the way give the answer also. First integration time, let me say T1 equal to first integration time, that is equal to 100 millisecond. So let me write down here, just give me 1 second. First integration time, that usually we call that as a T1, which is equal to 100 milliseconds. Good. And then dual slope ADC is operated in a continuous conversion mode. Good. The conversion time of the dual slope ADC, DS stands for dual slope. ADC means analog to digital converter, for an input voltage of 123.4 millivolt. Then what is the total conversion time? Total conversion time TC is how much? Clear? So I think that's actually the bridges I got confusion, but after your explanation, no need of formula, sir. Yes, good Raghuram. That's why I always say that I am not against of formulas. I am not against of shortcuts. But remembering too many formulas and going with a lot of shortcuts, sometimes it creates unknown pressure to you. Okay, whenever it requires, then only remember the formula. Whenever it requires, then only use the shortcut. If you try to use the shortcut formula, even in simple calculation also, you will do mistakes because of that. Okay. So, usually in dual slope conversion, the second integration time T2 is considered as the second integration time, which is equal to, basically in dual slope integration time, what we do is, we will integrate the reference voltage first, okay, or else, we'll integrate the reference voltage first, V reference into integrating time for some time, and then deintegrate with the input voltage into T2. Clear? Input voltage into T2. Now, if that is really true, then what we should say? T2 must be equal to V reference into T1, because the integration time and disintegration time. So let us see what it will become. T2 is equal to how much? T2 is equal to V reference 123.4, sorry, 100, this is. One second, the first integration time, the reference voltage first integration time. Okay. So T2 is equal to V reference into T1 divided by Vi. Please try to know the fact whether you are integrating the reference voltage first or the input voltage first. Okay. So let me show it to you what it will happen. Reference is 100 into T1, 100 into 100 divided by 123. So I think in this question what they are doing is, first of all, they are integrating the input voltage for some time. Okay. Later they are disintegrating the reference voltage. It is up to our choice. We can do in any way. Right? What is the conversion time? Conversion time means how much time it will take to convert the analog signal into digital reading. That is the meaning of total conversion time. Simple. So first we will integrate the input voltage. Later we will deintegrate with the reference voltage. Clear? Then in that case, deintegration time could be written as Vi into T1 divided by V reference. Clear? V reference. So what you will going to get now? It's easy. 123.4 divided by 100 millivolt get cancelled into 100 milliseconds. Correct? Into 100 milliseconds. Can you please tell me what is the answer here? T2 will be how much here? T2 is equal to 100. 100 will be getting cancelled. You will be having 123.4 milliseconds here. 123.4 milliseconds. Then T2 is this and T1 is this. Then TC, total conversion time. Total conversion time is nothing but the integration and deintegration time. Total conversion time TC, that is equal to T1 plus T2 here. T1 plus T2. What is the final answer? T1 is this 100 millisecond. T2 is 123.4 millisecond. When we add these two, how much you will going to get? 223.4 millisecond. This is considered as a total conversion time, right? So Mohan Sai, I think what we do here is in dual slope integrator, first we will take the input voltage and we will integrate for some time. We will integrate for some time. So this is the input voltage. This is the input voltage. Okay. Let me say this is the input voltage IV and this is the integration time. First integration time. First integration time. After completing the integration for some time, that is a known time, from there we will switch it to the reference input. That means we will terminate the input voltage and we will deintegrate the reference voltage for some time till we reach the 0th level. Clear? So V reference into T2 means reference voltage we will deintegrate for time T2. Normal voltage we will integrate for T1. Finally, the overall area what will be covered here, the overall area what will be covered, both must match. That is why it is called as a dual slope. The area that is covered here, the area that is covered here, both must be same. So when we equate this, we will get the deintegration time. Then when we add this deintegration time and integration time, then you will going to get the final total conversion time. Clear? And I know very confidently those students who know the concept, it is a cakewalk for them. They might understood this very easily. At least those students who attended my lectures or else watched the recorded lectures, they also might understood this question so easily. The students who doesn't know the concept of dual slope ADC, then they might face little bit difficult. For them, my suggestion is, first of all, go and watch the lecture related to dual slope. It will take maximum half an hour to 45 minutes, max 1 or 2 hours only. Okay. Then if you watch that, then you will understand that question so easy. Clear? So with this, I have done with all the major concepts of measurement. In fact, it is almost around 3.5 hours session. I really appreciate your patience and consistency and hard work and dedication. Love you guys. Simply take a bath, right? And of course, if you want to attempt the full length test, either subject wise or full length mock test, you can all the way go with this BYJU'S exam prep. Just go for the subscription. You will be able to get access to the full length exams as well as subject wise mock test also. Please do remember that without attempting the subject wise mock test, if you go for full mock test, then it is in vain. Okay, right? So good. Finally, last but not least, okay, if you want to get a continuous updates related to the classes and related to our special series, so you should connect to the channel such that you will always get the notification related to every activity that is going on channel. Once again, I repeat, thank you sir for complete revision. Thank you very much Mohan Sai, also to you, because it's been a great patience. I know teaching 4 hours might be easy, but listening 4 hours is really a challenging task. And I really appreciate your hard work and dedication and sincerity that is you have shown throughout of this long session. And I wish all the best to each and every student. If you have any doubts in control system, circuit theory and measurement and industrial instrumentation, please reach out to me. I am always here to help you. Once again, I am saying that stay connected to the channel to get the regular updates related to the all activities that are happening in the channel. So thank you guys, all the best.